got all the attendance timing. So yeah, if it is more than 30 minutes or 30 minutes and above, we just have to mark it that late. Okay, so if it is 1 day or 2 day, Asnet, to be honest to you, I can skip it. Okay, so I can just
But
ignore it.
what about somebody who never late? And
There
then
will be
all of
no late. No late. 1 day or 2 day is not a matter to me. I never give their late things. But if somebody is late every day or maybe in the week, 3 days, 4 days late, okay, so I'll be in
okay.
trouble because they can also keep track.
Okay. No, just
Okay.
wondering.
Yeah,
Okay.
yeah, yeah.
Yes.
If attendance at every day is very good, 1 day you are late. Okay, so that's okay. I don't mark it. Though officially I should, but I don't because
Okay.
I know everyone's. Now I know
Yeah.
everyone
I
who is,
understand. I
yeah,
understand you, miss. I
yeah.
know. It's
So,
me.
but if everybody can comes, in the 3 weeks or all day with the week for any reason, I understand totally the reason, but I also handicapped at some point from my side, right? Because they are going to blame me why you did that.
Yes.
Because
That's
some
true.
students are coming in right time, some students cannot for whatever reason, then they have to communicate with the school that I'm going to come every day 30 minutes late or 45 minutes late, like that. If it is 1 day or 2 day, everybody has that problem. I also have that problem. Sometimes I reach that 10 minutes late or something, not every day. But if it is the everyday problem, then we have to record it. And generally I don't mark it even 25 minutes, but even 30 minutes and above I have to do that.
Yeah. Just question, right?
Yeah, yeah.
Miss, I have an appointment today at
That's why, yeah, if you like goes appointment and other things, I never marked on this early leave. There is not only early come, there is also another option, early leave. If you leave early leave, I have to document it. But I don't do that really.
thank
I
you.
don't do that. Yeah,
Thank you.
yeah,
I appreciate it.
yeah.
Yeah.
Thanks, Mom.
That's why I instructed that give me all the attendance. I will do the attendance. You don't have to do the attendance. That's why I just wrote it there.
Oh, so you do all the attendance?
That's why I told I give that whatever the students will come, send me the report, who came what time, then I can do the attendance by myself. So
Okay.
that yeah, so I am taking care of the attendance, so don't worry for that. But
Okay, good.
that's why my questions, if anyone comes every day late, then I have handicapped. Even I don't want to, but I have to report it.
Yeah.
Report
Okay.
means I have to do in the attendance log, not report to anyone. So attendance log, I have to write the late. Okay, not how many minutes late or anything, we have to write the late. There is the option whether you are late and you are on time.
Because what I find that Miss, what's her name? She's very strict with that. Even if you're 5 minutes, she puts it down. Oh, this person late. This
Okay,
person
i
late.
i got, don't worry for that. I
That's
have
why
all the,
that's why I
she
was
wrote it down,
asking.
she sent it to me. If
Yeah.
somebody is late, who is absent, I have to document the absent, and if somebody is late 30 minutes plus, I have to document it. Otherwise I don't worry for that.
All right. Thank you. I'm
Yeah.
gonna be have an appointment this evening for 1 o'clock, so I'll be leaving a little bit earlier, but I will be on team.
Okay.
Thank you.
Okay. It is 55. This authenticator is killing me. Oh, for every step. So then I have to focus. When you go to the class on campus, remind me that if we have a new Holter monitor, we are going to show you how to put it. Okay, you have learned in the ECG how to put the Holter monitor, but we are going to show you how to do that, how it looks like. Okay,
Okay, miss.
remind me, otherwise I'll forget.
Okay, miss. Thanks.
Okay. Yeah. Laboratory. Okay, dear. Which one? Okay, where I have to go now? I have to go to D12. I'm already in D12. I'll do where is my phone? Okay. Clear all. Oh no, what I did clear all. I don't need to clear, but okay, so okay. No. Alexia 9:15, Yusra 9:10. So 29th who are absent. Monday who are absent?
I remember Ying Hong only, ma'am.
Only Ying Hong?
Monday.
And me, ma'am.
Huh?
Joanna.
Joanna,
Me,
both of you.
yeah.
Okay. Only
Chris.
absent. Okay, yes. Just give me a second. Just give me go on to the first campus login. Oh no, not login. Let me try this one on my sheet first. Okay. Instead of making any mistake, what is the attendance? Attendance. When you need it, you will not get it. Attendance, oh no, it's not coming like this. All results. Okay, my files, group H, attendance. So, 29th. Okay, copy, paste. Ying Hong and Joanna is absent, right? Okay, Ying Hong.
Chris too, miss.
Oh, Chris,
Wait,
yesterday,
Yeah.
Monday or Tuesday?
Monday and Tuesday.
You are off both days? What happened? You are okay?
No, I already emailed you regarding like I'm going home to Regina. So,
Oh, okay.
yeah.
Oh, you told me. Right.
Yes, yeah.
Okay. So, Ying Hong, Joanna. But Joanna, you are absent only one day, right? Monday.
Yes, just Monday.
Okay. And Chris only today. Okay. So, and today everybody is present. Okay, good. Paste. Okay. Uh, let me see what she wrote. One. Okay. So 29th, Alexia came at 9:15, Yusra came at 9:19, good. Huda 9:16, and Christiana 9:28. All are excused for that day. Okay. Let's see the 30th. Who did what time? Oh no, 30th, Luis was absent. Yesterday, Luis was absent.
Yes.
Yeah, you should tell me. Yeah, it's okay. Okay, copy. Luis absent yesterday. Okay, paste. And Chris absent. Late came Sabana at 9:30. Christiana 9:24. Kara 9:09. Forget it. Alexia 9:27. Okay. My God, she has so much time to document all 9:28, 9:15, 9:10, 98. Okay, good. Okay, so that and today,
Miss,
yes, today everybody's present. Okay, yeah, tell me
I
now.
think Savannah was absent on Monday too.
Oh, okay. Sabana, you're absent on Monday? Yeah, I think so. She wrote me that one. She told.
Yes, I think she's absent.
She's here today? Sabana? Sabana? Sabana, are you here?
Her name is in the Teams, but she's not responding.
That's the thing. That's the catch, That's the
Yeah.
catch. That's the catch. You cannot just put on the team, and that is more offensive. That means they think you are cheating. Ingong, how you are feeling now?
Thank you, Mom. I'm have the
Migraine?
Oh yeah, migraine headache. Yeah.
Yeah.
So yeah, thank you.
So how I'm going to put her, tell me the present today, Sabana. Yesterday she was in the class, Sabana?
Yes,
Yes,
Mom. She's present
yes, miss.
yesterday.
I have to keep her absent because it's almost 9:30, no response, right? This is my problem, I don't
think
like
we're all
to.
running from maths.
No,
Mom, I was at class yesterday.
who?
Mom.
Who is that?
Ingham was in class yesterday. Yeah.
No, yesterday Chris told she's absent. Okay, Sabana was late and Louis was absent yesterday. And Monday, Yinghong was absent, Joanna was absent, Sabana was absent, and Chris was absent, right?
Yes, Mom.
Okay. So today,
Miss,
Sabana, you have to put in absent
Miss,
because I am not getting her any response and all others are present. Yes. Any questions for anything? I'm going
She
to
said
do.
she's dropping her son at school. She'll be there in 5 minutes. She was on the camera before, I think. But she said she'll
Yeah,
be here in 5 minutes.
I understand. You understand they nowadays when there is somebody late, that's I'm telling you guys, they keep and watch on the video. It's already 9:30 now. I understand the problems. Yes, really is a difficult situation. Okay. I'm going to do that. I just recorded it, so I'll do that one later. So now let me go to the that is the username. I'll do that in a later. You'll go for break. So this one where the unit metric is our measurement. Oh, I have to go to the team again. I have to share, 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 share. Asnath, you are asking me something. Sorry, I just told you to stop. What happened?
No, Miss, you already answered my question.
Okay, thank you.
Yeah, you're good. You're
Okay,
good.
okay, okay, okay.
Mhm.
No, I'm going back
Hi,
and forth.
Miss.
Yes.
Yeah, sorry to interrupt. Shabana said she's dropping off her son, but she'll be logging in soon. She said like in about couple of minutes.
It's okay. I understand. But when
Yeah.
you are in class, you have to be in class. 1 day, 2 day, 3 day, this is okay. It's going to be
Yeah.
every day. Because they can watch it, they can rewind the video and do that.
Yeah.
So
Okay, Miss. I
I
just wanted
have
to
to.
let you know.
No, thank you. I'll write that one. I'll write that one that she's late for due to this reason. I just write all the reasons so that you guys cannot forget when they will if they ask you anything. If they may
Yeah.
not, but if they ask you anything and ask me anything too, so it's not be contradictory, right? So I don't like
Yes.
to be any students in trouble. I try to
Okay.
give whatever in my hand. I give more than that, but sometimes I am stuck also. They doesn't
Okay.
leave me also. Sometimes they doesn't leave me. We have to give answer. Why you did that? What you did that? Why you did this to student? So sometimes they thinks a lot about things also. Yeah.
Okay.
I'll
Thank you,
try to do
Miss.
my best. I try to do my if it is even 28, like you came at probably 9:28. I didn't put you late. It's okay. If it is 30, 9:30 and above, then I have to document it. Okay, so
Yeah.
let us see. Did
Okay.
you
Thank you.
learn about these things? Concentration of substances. There are different units. These are basically the units how we measure different things. When the concentration of substances, this is an example, millimole per liter. How much material or the substance is in the solution. It can be gram, it can be millimole, it can be different molar, different units, but it's going to be the concentration of substances we represent or we say as millimole per liter. Whenever we say something, how much potassium is there is 3.5 millimole per liter, means per liter. In whole liter, there is 3.5 millimole. If it is 100 ml, is 1/10 of 1000, right? So 1000 is 3 zeros after 1. 100 is 2 zeros. That means 110 is less. So if it is said that if I tell you potassium 3.5 millimole per liter means how much in 100 ml?
35.
No, it's going to be less than that. It's going to be
And
backward,
it
0.35 because it's
0.35.
less
Oh,
now.
sorry. Yes.
0.35 millimole per liter. When you are talking about the weights, universally, either we can give the gram because that is the universal unit, and also another measurement weight is pound. So if we say 22.3 gram of agar powder, you have to weigh to this much of agar powder. So we are going to tell how much you are going to weigh 2.3 gram, or in some other places when you to the grocery or something, you got weigh in the pound also. So now in Canada, you have the pound and gram, both systems. So that is the measurement of the weights. Volume, you already know, is 100 ml, 1000 ml to go to microliters from 1 ml, 500 ml, then 100 microliter, 500 microliter. So we have used the pipettes to measure that volume. So volume is basic units is milliliter. It can go up and below. Length, you can do the centimeter, that is the basic one, and also that is length or height. Both length and height you can do by centimeter or even the inches. So there will be a lot of inches to feet. So these are the basic things, inch or centimeter. Then you have to know the conversion. Temperature, we use 35 degrees centigrade incubator. The temperature, we say, what is the temperature of the incubator? 35 degree or 37 degree. These units are used in the lab. That's called the units of measurement in the lab. In the lab, we are not going to tell the Fahrenheit or inch or pound. You understand? So everything in the lab is use this system, this unit of measurements, these units, weights in gram, volumes in ml, length or height in centimeter, any concentration is millimole per liter, temperature centigrade. And time, we use
Celsius.
Celsius, centigrade or Celsius, yes. Centigrade and Fahrenheit, centigrade we call it the Celsius. That's the short term. And time is prothrombin time. It's a 12 second. So we go by the second or
Okay.
hour. So this is the we are using in the lab. That's why I told you that there is a, you can say, oh, pound is also the, the weight. But in the lab, we only use these units. So
Hi, Ms.
laboratory.
Manman. I'm here. Just wanted to let you know.
Okay, thank you.
Thank you.
Okay, so what I was. Okay. Laboratory results are used to establish a diagnosis. They are giving the value. What is the normal value to the abnormal value? So what we used, you establish a diagnosis, follow the course of disease, like who has the blood sugar or any other disease. So you have to do the follow-up study, right? How much was at the beginning, or whether after the treatment of the medication or some treatment is getting, or after the surgery, whether is getting better or worse, what is the value. And on the basis of that results, doctors prescribe the treatment method. So laboratory measurements have a direct impact on patient care. So you have to be very careful from starting from taking the blood to analysis and results. Important of proper use of units. It's a number without a unit is meaningless, right? If you say, oh, my glucose is 5, what is that 5 means? Nothing. It can be gram, it can be millimole per liter, it can be centimeter, it can be centigrade. So you need to specify a unit, and that unit has been established worldwide so that everybody who is in the whole world in the lab are using the same units for specific measurement things. So number without a unit is meaningless. To be any diagnostic use, laboratory measurements must be accurate, precise, reliable, and standardized. That's why before you measure doing your own patient blood study, you have to do the quality assurance, quality control, so that your instrument, your reagent, everything is working fine and giving you the exact result as per the manufacturer reference level. Must be reported with appropriate unit measurement. Say if you say the hemoglobin gram per liter instead of per millimole per liter, what is going to meaning? There will be no meaning of that. You have to redo the test. So you have to do the appropriate unit of measurement for each test. Must be compared to establish reference ranges. So that is what is the reference range? You have whether the value got, whether it's within the normal limit or the reference range, or it is below or above, it's hypo or hyper value. So that is very important. So what are the common used in US and sometimes in Canada but not accurate enough for scientific use? Scientific use, we generally metric use internationally. This is called the international units, metric units is the international use. We use the weight in kilograms, height in centimeter, cooking in millimeters. Cooking is not the cooking, is called the, the volume in millimeters, speed, kilometers per hour, fuel economy, kilometers per liter. We don't need this one per speed. But in USA, they can do. Sometimes in Canada, in some, that's why I told you, can the grocery stores, they can use it the pounds or sometimes the feet, sometimes cups, pins, and here miles per hour. USA is miles per hour, but we are kilometers per hour. So some of them Canada also use the mixed one, but in the lab, no matter what, you have to use this. Oh, sorry. You can never tell you are taking the measurement of a patient. You can tell, I can take the 5 feet high. Even you take the measurement, you have to convert to centimeter. If you are taking the weight in pounds, you have to convert to the kilograms or grams. So in USA, it can take weight in pounds, height in feet and inches, cooking TSP, cups, pints, those type of 1 cup, 2 cups. So when you are baking something, okay, I have to cook 1 cup of this powder, 1 cup of milk, or this cup of oil. But no, when you are doing something, we have to do the volume is a millimeter or liter. Speed mile per hour. Here we use the speed kilometers per hour. Ruler. This is the metric rulers and English ruler. Metric rulers are numbered in centimeters. One, you can see all rulers have both sides. One is the centimeter side and one is the inches side. So metric rulers are numbered in centimeters, so in increments of 1/10 centimeter or millimeter. So if this is 1 centimeter, this is 2 centimeter. So, and you can see there are 10 digits, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this goes in the 10th, 1 by 10th. So always there is a unique, sorry, equal space of 10 units are going to make one bigger value, or lesser value you have taken out the 10 units. So it's called the 1 by 10th centimeter or millimeter. This is centimeter and each one is millimeter. So this is, if we just say 1.1 means 1 centimeter 0.1 millimeter. So 1.1, 1.5 and then 1.10 is going to be the 2 centimeter. And English rulers in number in inches with increments of 8. You can see they have 8. 1, 2, 3, 4, 5, 6, 7, 8. So English ruler of the inches, they have a division of the 1/8, whether the metric rulers has 1 by 10th. Variation in practice. You may see American units in your studies such as gram per DL, when Canadian units use gram per liter. So deciliter versus liter. Deciliter is 100 ml. Liter is 1000 ml. This is not a unit used in Canada clinical labs. In Canada, we use this. The questions comes. What is the, how you express the hemoglobin concentration in the Canada in the lab is gram per liter. That's the questions come. Sometimes the question comes. What is the unit you use? So you should not be confused. We use the Canadian units as gram per liter. But USA does sometimes gram per DL. What is the international system? That is the system, that is the unit should be, is called the SI unit. International system of units, that's called the SI units. That is the universal, international. What is the purpose of SI units? As I told you before, purpose is to standardize scientific measurement worldwide, so that everybody by on a single expression can understand what is the result. It's not like they have to convert or this and that, everybody. Though till now different countries is different, using different units of expression. The value, if you convert, value will be the same. But you have to convert it when you are. But it should be. Some countries, sometimes they do their one unit, at the same time they put the value in the SI units. So that is the purpose, is to standardize scientific measurement worldwide. It is derived from the metric system of measurement and based on the 7 fundamental units which have internationally agreed on values. So whole world, what we showed before. So what are those? Length is meter. What is the abbreviation? Is M. Mass, kilogram, that is basically giving you the weight, kg. Time, we use the second, and abbreviation is S. You can do the second, hour or minutes is different, but it's the basic unit is second. Electrical current, ampere. Temperature, they use the Kelvin temperature. Whenever they come in the refrigerator on this and that, then they never used that the centigrade or Fahrenheit anymore. They use the Kelvin. It's called the K. Luminous density, candela, CD, and quality of substance. This we doesn't use too much. That is mainly for the spectrophotometer or kind of which is high kind of microscope or glass related things. But quality of substance is how you are going to describe how much is there concentrated of the solution is mole. These units are internationally agreed upon values, and the SI units we commonly use in the laboratory are calculated from them. So basic units of metric system, meter, M, basic unit of distance, either length or height. We are not going to tell the inch or feet. So if you say what is your length or your height or what is the length of these things, you have to use the meter or the meter and its subdivision. Mole, basic units to express quantities of substances. Gram, basic units to measure mass or weight. How much is there? What is your weight in gram, not in pound? Liter, basic units to measure the volume. And you have to know the units. Gram, we are not using gm. We can sometimes, but g, mole, ml. Larger or smaller units. Now you have these basic units. Then units value can be bigger or smaller. So that's why scale prefixes can be added to the basic unit to indicate the larger multiple of that unit or a smaller division of the unit. So say for example, basic unit for a distance is meter. What is going to be the larger unit? Kilo means 1000 is a gram. Kilometer is 1000 meter, right? 1 meter, when is a kilometer, is 1000 more. So that means when you do the kilometer, kilo means 1000. cm means 100. Deci means 10. So you said the kilometer means equal to 1000 meters. She did all those things yesterday, right?
No,
So
miss.
when you are going to the up, then it's the kilo. Kilo to meter is 1000 difference. So each unit has 10, 10, 10, 10. And when you are going below 2 meter, so meter, then you have the centimeter, decimeter, centimeter, millimeter. So when you are going to that, it's going to be division. This is less. If it's centimeters, means 100th. That is a decimeter. It's not here. Decimeter is 1/10. So centimeters means 100. Therefore, a centimeter is 100th of a meter. Sorry. And milli means 1 by 100 by 2h. So therefore, millimeter is 1,000. So that means it's going to be 1 millimeter means 0.0. It's easy to do in the board. Yeah. So basically 1 meter is equal to 1,000 millimeter. If we just think about that. I'm going to write it here also. Let me see. Maybe they will give later. Just let me see if I see same word. Everything is going to be the same. One is a kilometer. So what is going to decimate as km. You guys know this one, just so in between 1 kilometer to 1 meter, there is a 1,000. Insert steps. So 1 kilometer equal to
1,000 meters.
1,000
Meters.
meter. Okay.
Yeah.
Same thing. 1 meter is equal to is equal to
But are we
1,000 millimeter, right?
Yes.
millimeter? Yes. Yeah, this is centimeter. Yes.
Okay.
Yes, ma'am.
Okay. So if you say 1 meter means you have 1,000 millimeter. So 1 millimeter, now you can see each one has a 10 units, 1 meter to decimeter to centimeter to millimeter. Each are going by 10 units. Same thing for the meter. There are 3 of them: decameter, hectometer, kilometer. So is so different in the when was 1 kilometer means 1,000 meters. So what is going to be millimeter? 1 kilometer is going to how much millimeter? Can anyone tell me? 1 kilometer is equal to how much millimeter?
100,000 millimeter.
1 kilometer is equal to how much? How many millimeters? How many zeros will be there after 1?
6.
3
Six.
zeros.
6. 6. Yes.
Oh, 6. Oh, okay.
Yeah. Because 3 from here, okay, this is for the meter, 3 from here. Is that clear? So
Yes.
1 kilometer is 1000 meter. So I'm writing for the measurement 1000, right? Then I am telling this is the millimeter. Okay. So we are going to go down to the millimeter. So this value is up to meter. This is meter, right? So now I'm going to go to the millimeter. So it's going to be another 3. 1, 2, 3. This is from here. So then it's going to go to the millimeter.
Gotcha.
Okay.
Yes, ma'am.
Then you are going to give the power 10 to the power, how much power? 10 to the power 6, 10 to the power 6. Then we are going to express those the integers. Okay. So this is the basic things.
Yeah.
So that's why it's a milli means 100th. Therefore, a millimeter is 1000 of a meter. Is 1000. Meter 1, 2, 3, 4. So 1000, right? So 1000, then 10, then 100 is centimeter, then is going to decimeter, and then ultimately you are going to the millimeter. Same thing is going to be the happen here. Okay. Meter prefix case. So that is they are going to tell you how it's going to work. So matrix prefix case, how it's work, it is you have to remember a couple of them how the integers works. So this is the kilo and this is the millimeter and this is the none means 0, 10. When it's going to milli, it's going to -3 because you see meter to millimeter, right? This is going down 1, 2, 3. So it's -3. When it's going up, 10 to the power only 3, not minus. Minus means it's going down and up, that is nothing, means either plus or no value. That's why is the none is the middle one. When it's going to the millimeter, 10 to the power -3. More down, 1000 is micrometer, 10 to the power -6. We have more down, nano. All are going difference of 3 units, 100, 10, 10, 10. So it's going to be, you can see the unit is increasing or decreasing by the multiples of 3. 10 to the power -3, 10 to the power -6, 10 to the power -9, 10 to the power -12. At the same time, you go up scale from the meter or kilo, it's going to be the kilo 10 to the power 3. They didn't tell you meter or anything because it can be gram, it can be meter or anything. That is the how the integers or works. So none, that is means that is the middle one. That's a meter or gram or anything. Is the meter is going to the kilometer. It's a gram is going to the kilogram. So that is the middle one where there is nothing. That is the individual unit 1. So when you are going to the kilo, it's going to be the 3 times more. When you are going to the mega, it's going to be the 6 times more. When is the giga, 10 to the power 9, and tera is 10 to the power 12. And there is the division in between. That's why I tell decimeter, centimeter, what we told you before, right? Meter, decimeter, centimeter, millimeter. So from here, this is going down. Each is 10 units, 10, 10, and 10. So from meter to decimeter is 10 to the power -1. Means 10. When it's going to the centimeter is -2, means 100, less 100, and then 10 to the power millimeter. Same thing when you are going to up, you said the deca and hecto. Deca is +1, so 1 meter. If you are going up, it's going to the deca, or the decameter is equal to 10 millimeter. 1 decameter is equal to 10 millimeter. So 10 to the power 1. Same thing when you are going up, there is a hecto, 10 to the power 12. So each have the 10 units integers. When you are going down, it's going to be the minus. When you are going to go up, it's going to be the, it doesn't say plus, but the integers has the plus sign. That means you are going up. And each is multiplied by 10 units. 10, when you are going to the 10 times 2 means 10 plus 10 is not 20. Is when is the power means you have to multiply with the same number. 10 times 10 is going to be the same thing here. Ultimately is going there like this. Okay, now we are going to convert these. You guys have to remember convert. So what is 494 liter is equal to how much ml is going to be? This is for your practice. What is this one? You are going to practice it. Just give me one example. 494 liter is equal to how much ml?
0.494.
Huh?
494,000.
494,000 because it's going to be multiplied liter to ml, right? 1 liter is equal to 1000 ml, right?
Right.
Everybody is clear? So if I just meter, if I just change it the liter, it's going to be the same thing. 1 kiloliter or 1 liter is equal to, this is here. So liter, meter. So liter, if I just change this to the liter, that means it's going to be 1 milliliter. So 1 liter is equal to 1000 ml, right? If I say 4 liter, so it is going to be how much ml?
4,000.
4,000.
4,000.
So
4,000.
yeah, so it's going to be multiplied 1000 multiplied by 4. You got it. So this is the same thing. 494 liter means 494 times 1000 because it's conversing using ml, right? Same
Yeah.
thing, 7.3 liter is going to be, tell me how much is going to be the
7,300
is that right?
ml.
7,300.
Milliliters.
Yes.
Just give me a second. Yeah, 7,300 ml. Good. The same thing for 97.6.
97,600.
600.
ml.
97,600. So you can understand it just conversion. Now you are converting. This is the unit of liter is unit of
Volume.
volume. So now if you are going to the unit of weight, kilogram. So what is going to be the kilogram to gram?
1,000.
1,000 also, ma'am.
Yeah, so
1
935
kilogram.
times 1000, right?
Yes,
Now
ma'am.
they are going to come back. Now see, they are telling this is the milliliter. Okay,
Mhm.
so see, you are converting to the liter. What you are going to do here?
Divide.
Divide.
Thousand.
So yeah,
1,000.
good, very good. So what is going to be the value?
1.667 liters.
1.667. Very good. This is from gram to kg. Whenever you are going to see the question, make sure what they want the conversion. Okay, from where to where you have to divide or you have to multiply. So okay, this is see from gram to kg. So what you are going to do is going to multiply or divide.
Divide.
Divide. Okay, divide by
1,000.
1000. Good. So now you can understand what you are going to do here, right? I am not going to
Yes, ma'am.
repeat it. You can go and practice as much as you want with the integers, points, decimals. Okay.
Okay,
So this
ma'am.
I'm not going to here. So this is the millimeter to centimeter. Oh, there is one millimeter to centimeter. What you are going to do here?
Multiply by 10.
How much? Millimeter to centimeter divided by 10.
We have to
Multiply.
convert first to meters, ma'am, then
Divide
convert
by 10.
meters to
Yeah, divide.
centimeters. I would say. It's
Divide by 10.
Yeah.
divide by 10.
Yeah, good. And
By,
millimeter to centimeter?
Divide by 10.
Divide by 10 the value. Divide.
I don't think so. Oh, no, millimeter to centimeter. Yeah. Divide by 10. Yeah, I'm just thinking the opposite direction. Yeah. Millimeter to centimeter divide by 10. You guys are right. Thank you. So that part is done. Everybody understood what to do?
Yes.
Okay, clear, right? Good. Okay, so now we are going to the temperature. Just give me a second. So we told that we express Celsius. We have temperature, Celsius, Fahrenheit, and this we are telling because we have to convert, and we also use the Kelvin as an SI unit. So Celsius, this is although initially derived by the freezing point of water from where it came, the Celsius, and later the melting point of ice. The Celsius scale is now defined the relation in the Kelvin temperature scale. So from where it generates? Celsius, the water freezes at 0 degree Celsius. At the same time, 0 degree is the melting point of the ice. There is a latent heat. That I am not going to describe. When you take from the 0 degree some latent heat, it becomes ice. And when the latent is going there, is going to be melting point. So basically 0 is the freezing point. At the same time, 0 is the melting point of the ice. And from there, the Celsius case, Kelvin, that is the K, has been established. So 0 degree centigrade or Celsius is equivalent to 273.15 K. This conversion, you have to remember, this we can teach it, but this is it has to be in your memory. What is the conversion for different units? If you remember only one, then you can convert it. And Fahrenheit is thermodynamic temperature scale. The freezing point of water is 32 degree Fahrenheit. When is 0 degree centigrade, you guys all know 0 degree centigrade is equivalent to 32 degree Fahrenheit. Again, the freezing point of the water 32 degree Fahrenheit and boiling point is 212 degree Fahrenheit. But you can always see in the autoclaves and other things, we always speak about the centigrade. So,
Ma'am, I have a question.
yes.
Thank you. The 273.15 K. What is unit K mean?
Kelvin. That is the international unit for the temperature you use.
Kelvin. Okay.
Kelvin.
Okay, I see. K temperature.
Okay.
Okay, so usually we use the degree
We
and
call centigrade Fahrenheit, but when the manufacturers or anything will come, they are going to tell you the Kelvin. When the minus temperature, the minus freezer or this and that comes, the international unit. Here we understand we can use the centigrade or Fahrenheit, but in the lab or the international system, you have to use the Kelvin, and you have to know what is the conversion, how you have to convert. So 1 Celsius is equivalent to 273.15 Kelvin.
Thank you,
1
ma'am.
or 0 degree Celsius is equal to 32 degree Fahrenheit. So that is the conversion you have to remember, so that if somebody tells you to convert from centigrade to Fahrenheit or Fahrenheit to centigrade, from Fahrenheit to Celsius or Celsius to Kelvin, so you have to remember the conversion. What is the conversion factor? So 1 Celsius is equivalent to 273.15 K. If I say 10 Celsius means equal to 273.15 times 10 K. So that is the conversion you have to remember. So 1 degree centigrade, 0 degree centigrade is equivalent to 32 degree Fahrenheit. So when is 90 degree centigrade, 9 degree centigrade, what is going to be the Fahrenheit temperature? So that is the conversion you have to remember. So how you are going to convert Celsius to Fahrenheit? We have formula for that. Celsius means centigrade, or Celsius to Fahrenheit conversion, multiply the centigrade temperature by 1.8 and 32 this number. So Fahrenheit is equal to centigrade. What is your centigrade temperature? Times 9 by 5 is equal to 32. Is going to give you this value. And Fahrenheit to Celsius is this formula. When you are going to do centigrade, is equal to, you have to have the Fahrenheit temperature. Say if they are going to give you 100 degree Fahrenheit temperature, what is equivalent? Say for 132. So what is going to be the equivalent of your centigrade? So you have to put the 100 Fahrenheit temperature minus 32, then times 5 by 9 is the opposite. So you have to remember these two formulas when you are converting from Celsius to Fahrenheit. That means when you are looking on Fahrenheit temperature from Celsius, you have to follow this one.
Ma'am, there's a typo
Ma'am, excuse
error.
me. Yeah, there is a typo error. The formula of
Equals
Celsius to
32.
Fahrenheit. It
The
should be plus
plus
32,
32.
not equals.
This one, this
Yes,
one,
ma'am. Yes,
this
Yes.
ma'am.
one.
Yeah,
Yes,
yeah,
ma'am.
Yeah,
yes.
this
That
is will
one.
plus. They always.
Yeah.
Basically, what formula I follow, only one formula. So what I see, let me
Mhm.
see. Insert save. I remember why. I don't know how to do that though. Or if I just do like this one, see. Bye. I just remember this formula whenever there is anything. So if I have to find out the C, so C by 5 is equal to, I put the F value here and then do this one. When you have to find the Fahrenheit, so just the opposite one. So I just use only one formula, but here I have to write it down. Oh my God. So let me print screen. Where is the print screen? Print screen. Oh dear. Okay, so I'm going to report it. So you guys know how to do the conversion. So this is the things they are giving the answer. You can check it. This one, convert 26 degrees centigrade to Fahrenheit. So they give you the answer. You can check whether they give the right answer or not, because I don't trust detail everything.
Ma'am, the number
Okay.
1 is wrong.
Number 1 is wrong.
Yeah,
Mhm.
my answer is 46.8.
My answer 78.8.
Oh, sorry, it's the Fahrenheit. I reversed it. Yeah.
Centigrade to Fahrenheit. So it's going to be more, right?
All are correct, ma'am.
Yeah, yes, ma'am. I
Yeah, it
reversed
should be
the
more.
number
Yeah.
1.
Centigrade to Fahrenheit. So value should be more. Yeah. So you guys can check it and make it. I'm not going there. And also practice, okay? So instead of looking at this answer, first practice this one and check answer. And if there is any mistake, let me know. Okay?
Okay, ma'am. Thanks.
Okay. Now exponent. What you mean by exponent? What is the how many times it is coming? That is the exponent. Exponents are used to indicate that a number must be multiplied by itself as many times as indicated by the exponent. So same thing is coming 4 times, 4 times, 4 times, 4. You are going to write, instead of writing like this, what you are going to write in the short form, and you can understand what the exponent number means. So number to be multiplied is called the base. This is called the base number. Which number we are going to multiply, and that is the power. What we are going to, how many times we are going to multiply. The base is the number which is going to be multiplied, and power is the how many times you are going to multiply. So exponent is written as a small superscript figure to the immediate right of the base figure. That is the base figure on the top in the immediate right is as a superscript and can be called the power of the base. We call the power. Example, 153 times 2 means this is the base 153, and how many times you have to multiply? You have to multiply one time 153. There will be two 153. So 153 times 153. If it is 153 to the power 3, means you have to multiply. This is the base 1, then 2 times 153 times 153 times 153. So 153 is the base figure and 2 is the power of the base. So how many times the power? That means the number, base number is going to appear that many times. If it is 3, 153 is going to be appear 3. If it is 10, then 153 is going to be multiplied by 10 times. Clear? Say example, 4 to the power of 4. So this is the same as 4 times 4 times 4 times 4. 4 is the base. And how many times it has been multiplied? The 4, 1, 2, 3, 4. So 4 to the power 4. Sometimes they will give you in this way and tell you to make a power. And sometimes they will give you the power to make it simplify or give the value. So 4 to the power 4 means how much? So you have to see this is the base and this is the power. Power means how many times the base number is going to be multiplied. So what is this one? If I say 52 to the power 9,
So 52 times to the 9.
9 times.
Yeah. 52 times
9.
Exactly.
Not 52 times 9.
52
Not
times
2.
52.
That is that's why I just gave you. Not
Yes.
52 times
52
9.
multiplied by 52 9 times.
Yeah, to the power
Yeah,
of 9.
52 times 52 times
Yes.
52 like
Yeah.
this.
9
Okay?
times.
Nine.
Yes.
9 times 52 is going to be itself, not that people made a mistake. That's why I just give you. Some people,
I hear you.
52/9, they are going to, they are going to multiply 52 times 9. It's not that. The
Yeah.
same base unit individually has to be appeared and multiplied by each other. Okay? Two, three, four, five, six, 7, 8. So you understand how much is going to be? This is going to be how many times now? See, 52 to the 9, 52 is our base, and
Mhm.
9 is our power, right?
Mhm. Mhm.
So that means 9 times 52 has been multiplied individually. So 52 times 2, 3, 4, 5, 6, 7, 8, 9. It is not 52 times 9, not. Okay, so
True.
that is the maximum mistakes happen. So whenever it happens, what they does 52 times times 9. People make these mistakes. That's what I'm giving you. So power means not 52 times 9. Power means this base number has to be multiplied the same number of times what is it says power. Is that clear to everyone? Don't do this mistake. Maximum times I saw the students mistakes do the 52 times 9. Okay?
Yes, ma'am, it's clear. Thank
Okay.
you.
So now how you are going to rounding the numbers? You have learned this one, right? Yesterday?
Yes, miss.
Yes,
Yes.
miss.
Okay. So this should I go in or you guys are okay for this one? Generally rounding you have to closest to the decimal point. That is the rule. The nearest to the whole number. To one decimal place. If there is only one, so one decimal place, the nearest to the hundredth. What is close to that one? After that, that is the rounding principle. Look at the next digit. If it is less than 5, round down, equal to 5 or greater than 5, round up. So this is 4.6. What is your closest value? 4. And this is above 5. So what is going to be rounding number? 5. This is the whole number. Here you have the decimal, 5.498. So what you are going to say? This 8 is above 5, number 5, right? 5 and above is going to round up. So you are going to make this one. You have to add 1 here. So it's going to be 5.5. So when you are adding 0.49 into 1 is going to be 5, right? 49 plus 0.01 is 5. So it's going to be round up by 5.5. If the value, say for example, if the value here it was 4.492, what is going to be your rounding value? Instead of 8, it was 2. So how we are going to end it up with the value? 5 point what?
5.
5.5.
Yes.
No.
5 point, because the
5.50.
5.0, 5.50.
Okay. I'm giving you.
Depends on how many decimal point you want us to do, though.
This is 5.
Yeah.
Okay. This is agree, everyone?
Yes,
Yes,
ma'am.
Point, what is this one? Value.
So 5.5 is 6.
5.498. 5.498. Okay. I'm giving you to round up. What is going to the round up? This 8. This 8 is above 5, right?
Mhm.
Yes.
Like this 6 is also above 5. So we are rounding up to the closest number is going to be the 5.
Yeah.
Mhm.
Okay, so up. Here we are rounding up to the closest number, not here.
Mhm.
Closest number. So you are going to do 5.5. Sorry, 5.5, right?
Yeah. Yeah.
Yes.
yes.
Okay, okay.
Miss, I have a question.
Okay. Okay, what is going to be this rounding value now?
5.49.
5.4. So that was you guys are making mistakes. So don't do that. This 2 is less than 5. Okay.
Yeah.
Mhm.
So it's going to be, it's not going to be added.
It's
Not going
not
to be
gonna change.
subtracted. It's not going to change.
Mhm.
Yes.
Okay, Asnath, what is your question? So it's clear now, everyone? If it is
Yes, ma'am.
now,
Yeah.
it depends upon how they want to round. It says the closest decimal point or closest to the whole number. Say for example, place. Okay.
So
Yeah, that's right, ma'am. Closest to the whole number.
Yeah.
Also.
So tell me, what is going to be this value?
5.
5.5.
Third.
5.31.
5.31.
Yes. So the 6 is more than your
5.
5. So it's going to be
Yes.
added here. So just copy. Is everybody understanding or just hearing and then we'll make the mistake? If anybody have no question, remind.
Understand.
Yeah,
I
just
have a
ask
Understand, ma'am.
question.
No, I am asking everyone who is not participating at all.
Yes, miss, we understand.
Okay, so
Yes.
now tell me. Now
Yes,
tell me
ma'am.
what is going to be the value?
Ma'am, how many decimals should
522.
should placed in usually in lab? How many decimals?
It depends
Two?
upon what. Generally two, but it depends upon sometimes some very micro quantity. Sometimes we have to go up to 3.
Okay, correct. Thank you.
Okay, so tell me what is this value?
5.22.
5.21.
5.2.
Two.
And what is
22.
going to be the round up?
2.2.
22.
5.22.
Yeah. $5.1.
5.1.
Yes.
$6.
Good. Rapid answer. So conception is clear?
Yeah.
Yes.
Yes,
Yes.
ma'am.
Everyone?
But I have a
Yes.
question.
ma'am.
I have a question for you, Miss. I have my hands up for a while now.
Yeah, I didn't on the team. Sorry for that. Yes.
So for
Yes.
that 52 to the power of 9, I just want to go back a little bit. The 52 to the power of 9, this is the answer you're looking for, 52 times 52 times 52, 9 times? Okay. Okay, that's the answer you're looking for. Okay.
Yeah. So
No
I'm just
problem.
giving the easiest one. So 2.
Yeah. Okay. No
Yeah.
problem.
So you can get the answer, right? So 2.
Okay.
Yeah.
Got it.
Yes. So it's going to be 2 times 9 times, right?
Yeah.
So multiply, so you can get the value.
Yeah. Got it.
So 2 times 2 is 4, then like this, and you have to continue
Yeah.
like this.
Yeah.
Okay.
Yeah. Mm-hmm.
Everybody is clear now? Probably you all did this
Yes.
yesterday, right? So it was
Yes.
clear from yesterday. You already did it yesterday? all these things?
Yes, we did.
I don't remember the kilometer or the millimeter one, but the other ones, yes, we did.
Kilometer, meter, those are the units. So anyway, they
Yeah.
can tell you the 52 turns of 9
Yeah.
kilometers, how we are going to simplify it. Or so then you don't have to ignore the units. Then you have to follow this one. This is the power and this is the base. How many times I have to multiply to express in that unit?
Yeah. Got it.
This one is done. Now rounding is already done, although useful for many applications. Standard rules are not useful for statistical analysis. They skew your data in the upward direction. Keep in mind that when you round up, it doesn't need to the statistical, so don't worry for that. So these are the couple of examples with the rounding you are going to do. So what is means? 3.1 means minus 0.1. It's not error, it's they said error, but that is a value. So how is that 3.0 means 3 is unit, 3.1, 3.2, 3. This is going to the minus direction. When it's 3.5 is rounding up, plus, 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 plus. So when you are down, it's a 3, 3, 3 rounding. When it's going to 5 and above, it's going to round up to 4. Same thing that we have learned, okay?
Mhm.
Here is the problem. With standard rounding rules in any given body of data, but not all upward rounding errors are balanced out by download rounding errors. Let's review the standard rounding rules. Look at the next digits. Yes, it is less than 5, round down. Greater than 5, round up.
Round up.
Is it equal to 5? Round up. So don't make any mistake. It's 5 is round up. Okay? 5 and above is round up. 5 and down is round down. As said, equal to 5 problems. Statistical rounding rules. Statistics will never leave you. So look at the next digit. It's less than 5. Round down, greater than 5, round up, equal to 5. Does anything other than zeros follow the path? So if so, round up, pass the half. Nothing other than zeros follows. Doesn't need that. This is for the statistical analysis. They does that. So it's going to be 4 plus 0.5. No, it never does that. What they're telling. For the statistical analysis, you doesn't need that. This is you doesn't need it. Okay, significant digits. Using more digits than necessary for precision is misleading. In that it ascribes more accuracy to the determination that is actually the case. So if you are going to 0.0000323, so using more digits, sometimes that's why it's rounding up is very convenient. Digits in a number that needed to express the precision of the measurement from which the number is derived is known as significant figures. So here, what is the significant figures? What is the main from where it originates? That is the significant one. And then this is the past point or fractions. So then take the accuracy of the least accurate measurement or the measurement with the least number of significant numbers. That's the accuracy of the final results. How we are going to do it? So they are going to give you the calculation, cannot increase any accuracy. So mathematical calculation cannot improve accuracy. Therefore, when adding, subtracting, multiplying, or dividing approximate numbers, the answer cannot be more accurate than the least accurate measure used in the calculation method. However, you are going to use the least. Say, what is the method of calculation? So convert 254 pounds to kilogram. What is the conversion factor? Pounds to kilogram. Kilogram. You have to multiply it by 0.454. This you have to remember. When they are going to come in the portion, convert pounds to kilogram. There is again another conversion from the kilogram pound. Those factors you have to remember. That is you have to memorize. So if you just convert pound to kilogram, how you are going to do it? 254 times 0.454, which is giving you the 115.316 kg. Right? So 254 pound is equal to this kg. So do we report in all these digits or do we round it off? Answer cannot be more accurate than two numbers we use for the calculation. So here you have to round it up. The number of digits kept is determined by the least accurate number used in the calculation. For multiplication and division, the least accurate number is considered to be 1 with the least number of significant digits. Here you can tell in the weight wise, oh, you are 115.3 kgs or 32 kgs. Or you can tell the kg approximate 150 kg when you are giving the weight. But if it is for giving you some values of the blood test and other things, you have to keep it minimum 2 decimal point. Now, what are the significant digits and figures?
We don't hear you, ma'am.
Yeah, just give me a second. Significant digits, so digits in approximate number or digits in approximate number which are meaningful are called significant digits. For example, I have 4 identical jars of jelly beans. I want to know how many jelly beans I have. Still, I can count all the jelly beans in each jar and added them at. I would know exactly how many jelly beans I have, or I could approximate. I know that each jar holds about 200 jelly beans. So that is the approximate. So it says, say for exact count, jar 1 has 203, jar 2 has 195, jar 3 has 201, jar 4 has 206. So this is the exact count when you are counting each can or the jar. But in general, what is the idea? Oh, these jars can hold approximate 200 jelly beans. So when you are do the exact count, it is going to come 805 jelly beans. All the digits in the numbers are meaningful because my count was accurate down to the last bean. But approximate number for jars approximately contains 200 per jar. So approximately 800 jelly beans. So not all the digits in this number are meaningful. I don't know the last bean how many I have, not even the closest 10. So here you have no idea. So this is the approximate number and this is the exact number. The temperature. Sometimes meaningful is determined by the usefulness of the information. Even I had a thermometer capable of reading accurately to 1 decimal place for the weather. It is not useful to know if it is 34.3 degrees centigrade versus 34.4 degrees centigrade. Either way, it's hot or no value is added to the reporting the extra digits. Do you think the 34.3 versus 34.4 will give you temperature wise any big difference? No. You are going to feel 34. That's the thing. So a report temperature is 34 degrees centigrade. So whenever they give the temperature, they give you 9 degree or 4 degree or even it's a 4.5 or 4.3, but it's a round. It doesn't matter. So this is for the temperature. It doesn't matter for 3.1 difference in the centigrade. Celsius or even the Fahrenheit. It's 1, 2, or 5 digits, it doesn't matter. So either way, it's hot no values is added by reporting the extra digits. I know 34 degrees centigrade means hot temperature. That's we understand. Whether 34.3 or 34.4, it doesn't feel that much difference, or it doesn't meaning anything to us. 34 is 34. If it is 38, then we can add that is more. So it says the range 34 to 38. Oh, that means the temperature can go up to 38 degrees centigrade, but it doesn't matter 38.1 or 38.2. So here's the whole figure is more matter. So that is the either way is hot, and no value is added by reporting the extra digits 0.3 or 0.4. So we just round it to a whole number and report it as 34 degrees centigrade. Assume that all recorded non-zero temperature 1 to 9 digits are significant. Assume that those are not meaningful who are rounded up before recording. Say example, outdoor temperature is 34.3 degrees centigrade were rounded up and they reported at 34 degrees centigrade. And this temperature has only two significant digits, 33 and 4. So these are the two significant digits we have in this temperature. This is not needed or is not getting has any value because we have to round it up. What about the zeros? Sometimes they are significant and sometimes they are not. Sometimes they are only serving as a placeholder so that we correctly interpret the number value. Example, approximately 800 jelly beans. So it says, since I do not know to the closest bin or even to the closest 10, but only the closest 100 is the 8 is meaningful. 800, the 0 doesn't mean to us. So only the significant number is only 8. So 8 is meaningful. If this value changes, then the whole number is going to change. So 8 is meaningful. Digits in this 10 place and the ones place are not meaningful. The zeros are needed only as the placeholder so that you can say how many hundreds, 800s. If you change this value, 500, but this zero doesn't give you any exact figure, exact value, whether it's 805, 18, or 812, or 15. So when they have these numbers, then they are going to be the significant values. But here, the zero is telling you the amount, not the significant number. So if I drop the zeros because they are not significant, then the number 800 will become 8. Right? So if you think 800, I like to, oh, that is no significance. There is significance, but it's not the significant number. These 00, the placeholder has the significance in telling you how much or how many, but that is not the significant number. That is the difference. Significance and significant number. Significant number is going to tell you the what amount is there. And placeholder is going to give an idea how much. So it would become 8. So if you drop, oh, this zeros has no significance. So if I can drop it from 800, it's going to 8. So it became 8, and you are going to misinterpret the result. You are going to consider my whole jelly bean instead of 800 approximate, I have only 8. So zeros cannot be dropped because they needed the placeholders. So now, again, 3 significant digits, 198, 204, all are significant digits. Exact total 800 jelly beans. So all 3 digits significant. I have exactly 800 to the last bin, not 799, not 801. So exact total amount you have 800. So here again 8 is the significant number, but individual jar has 3 significant numbers, 198, 204, 197, 201. So 200 per jar, 4 is equal to 800 jelly beans. Although they may happen to be exactly 800 beans in the jar, I have no knowledge that based on this less accurate method of measurement. So this is the significant. What is the difference between significant or non-significant and the placeholder numbers? So what are the rules of zeros? Without knowing how things were measured, we need to be able to determine whether zeros are significant or not. If they fall between other significant digits, they also be significant or sandwiched. Like example, 805. This has 3 significant digits. Although 0 has no value, but it is in between 2 significant numbers. That is called the sandwiched. So 3 significant digits, which exactly 800s, 010 and 5 ones. Right? 1, 5, 8, 100, 800, 0, 5. So this has 3 significant digits. If they are to the right of the non-zero digit and to the right of a decimal, they are significant. Example, 4.200 has 6 significant digits. 1, 2, 3, 4, 5, 6. When it's after the decimal point, the zeros has a significance because this is going to give you the fraction. Zeros after a decimal can be dropped without affecting number in interpretation. They are not needed as placeholder. So if they were recorded, it was intentional because they are significant. Not, for example, at the exact number after 234, then it's going to be 199. You have to have the 3 significant digits. Because when you are going to convert it, it's going to give you the fraction different. Final zeros at the right of a whole number are not significant unless marked to indicate. So example, 800 has 1 significant digit. So when 8, there is something marked on the top, that means 8 has 2 significant digits. When they have mark in the 3, so it's going to be written style, 3 significant digits. If the recorded intents or asked to know the zeros are significant, a bar will be placed over the last significant zero. Then this zero is going to be considered as significance. Initial zeros to the left of the non-zero digits are not significant. Example, 0.05. It has 1 significant digit, 5. The zeros and placeholders to assist the number interpretation. This means 5 by 100. But these zeros has no significance, but you have to place it because you can understand only significant number is 5. So it's 5 means it is 100 of a 5, 5 by 100. So if we drop the zeros and recorded is 0.5, if you think, oh, 0 has insignificant, there is no value. So then if you drop this one, it's going to 0.5. 0.5 means 5 by 10th or 1/10. So it's going to misinterpret the number. So after the decimal and between these significant numbers, what is in between has a significance. So ignore all initial zeros, ignore all final zeros unless they are to the right of a decimal or there is a bar to indicate significance. But the zeros on the right of a decimal, you cannot ignore. And if there is a bar on the top of the number, everything else is significant. So you have to practice this one. Okay, this is your practice things. You can do practice at home. What is the significant digit practice? So this is for your home. You have to do the practice or you can do in the group. What that means, I don't understand though. Oh, how many digits, significant digits is have? It's telling, okay. 1 has 2 significant digits, 2 has 2 significant digits, 3 has 4 significant digits, right? And this one has 5. 1, 2, 3, 4, 5, because after the decimal. This one has 1, 2, 3, 4, 5, 6 significant digits, 100%. This one, 1, 2, 3, 4 significant digits, and this is 5. This is 1. This one, 0.02. This is has only 1 significant digits, and this one has, this is the bar here, right? So 1, 2, 3, 4, 4 significant digits. Understand the practice?
Yes, ma'am.
Okay, good.
Yes,
So,
ma'am.
so this is, we already did it. Convert 254 pounds to kilogram. 254 times this one. So ultimately, you are going to depot as 254 pounds is equal to this amount of kg. Do we depot it with all those digits or do we round it up? The answer cannot be more accurate than two numbers are used for the calculation. Least accurate number, we already did it. Multiplication, division. How many digits to keep? 254 has 3 significant digits. 0.545 has 3 significant digits. The answer cannot have more than 3 significant figures. So round the answer is 115 kg. So you are rounding them. You are not going to tell that's why I told you the weight you cannot tell that is going to 115.316 kg. Generally you say the round up figure. Round up the figure is, and this is if this figure was more than 5, then you have to report 116 kg, right? 5 and above, right?
Yes, ma'am.
Okay.
Yes, ma'am.
As it is less than 5, so we are rounding up to 115 kg.
15.
Yeah, so least accurate number is considered to be the one with the least number. So 6.3. So what you are going to do? Exact rounding up, 6.2 plus 4.12 is coming at 10.32. This 2 is less than 5. So we are rounding up to 10.3.
10.3.
Okay. So when you are doing the subtraction, is coming 798.88. So you are going to round it up to, this is the closest, right? So rounding to 799. When digit next to last one to be retained as less than 5, that we told the last digit should be left unchanged. When the digit next to the last one to be retained greater than 5, last digit is increased by 1. If the additional digit is 5, the last digit report is changed to the nearest even number. Scientific notation we already did. To express numbers that are too large or too small to be conveniently written in the decimal form, also referred to as scientific form, m to the power 10 to the power. So let us go for break, then we can go from here. Scientific notation. We already learned that one yesterday, right? Did you?
No, ma'am. Scientific notation, no.
Okay. So there are two slides. Let me do this one, and then we can go for break. Okay. Scientific
ma'am.
notation and scientific notation. This is way to express the numbers that are too large or too small to be conveniently written in the decimal form. Decimals means the point, 100 or division. Also referred to as the scientific form. Just give me a second. So, in scientific notation, non-zero numbers are written in the form of a factor like this. This is the again the base, and then you have to write it times 10 to the power, or m times 10 raised to the power of n, where n is an integer. This is not called the power anymore. It's called the integer, and the coefficient m is non-zero real number. So basic, this is the coefficient number. This is going to be the real number. And this is going to be the how many zeros you have to do the scientific notation. So n is called the integer or the exponent, as we call the power. Exponent means when you are increasing. So for example, you have 3500. This is a very small example, 3500. You can write it, but you can write it at 3.5 10 to the power 3, or 35 times 10 to the power 2, or 350 into 10 to the power 1. What that means? 3.5. After this 5 means you have 3, total number of 3, 0.500. Or if you just 35.1 10 to the power 2 means you have to have 2 zeros here, right? So 3500 is going to be multiplied the exponent. You have to multiply with the 100, multiplied with the 3. So 1, 2, 3. So 3500. 350 by 10 to the power. How many integers are there? That means that number is going to be multiplied. So 3.5. So you are going to move 1, 2, 3. So you are going to move this point. 1, 2, 3 is going to be 3500. Same thing here. 35 10 to the power 2. So you are going to move this 0 to 1 and 2 is going to be 3500. Same thing here. Can be positive or negative numbers and integers. What would 1, 2, 3, 0 will be scientific notation? So let us see how many. 1, 2, 3, 4, 5, 6. Because this is the base number, right? We cannot change it. So it's going to be 1.2304 times 10 to the power, because these two numbers is not significant anymore. But you have to calculate it. 1, 2, 3, 4, 5, 6. So you have to do 1.2304 into 10 to the power 6. This is, can you just give me a break? Yes. Hello, Saina. Yes. Okay. No, yeah, they are okay. They are fine. They are fine. I'm just, yeah. I'm going to give you the break time because I'm just completing 2 more slides and then they'll go for a break. So, no, it's okay. You are in class? Nora. Okay, thank you for taking the class. Yeah, okay. Thank you. So, we'll see you on Wednesday, next Wednesday, okay? Okay, thank you. Okay, bye. Bye. So you understand this one, right? This is called the scientific notation. And this power is called the integer and it goes in the multiply of 10. Not that one when you are going the exponent like the 4 times 4. That is the same number is going to be multiplied. And here when is the scientific notation, that means you are multiplying. Instead of writing the huge big number, what you are doing, you are writing in a small form. But you have to represent in such a way that it's going to give you the exact value. If you just eliminate these two numbers, oh, this is the non-significant numbers, but you are not including is your integer, what is going to be ended up is 10 to the power 6. Oh, I owe 1.2340 times 10 to the power 6 amount of money. So that means they are going to get this amount of money, not up to this. So you have to consider this one for your scientific notation for the calculation. 1, 2, 3, 4, 5, 6.
Isn't that right, ma'am? That 1.2340 or 1.2304 times 10 to
That
the...
is a mistake. That is a mistake. That is a
Yeah.
mistake, right? Yeah, it
That's,
should be like this. Yeah. They made a mistake. Instead of putting this in 0, it should be 1.2304. There
That's
should
right,
not be
ma'am.
needed the 0. Okay?
Yes.
Yeah. They should do that 1.2304 times 10 to the power 6. What they did?
Yes.
My God.
That's right.
It's
Yeah.
a typo error.
A typo again.
It's break time.
Not at all. Oh my God.
It's break time.
Not Asnet. Who told you break time? We have no break. Okay. No,
That's
not
why
this
it's
one.
over.
What? No. Just give me a second. Just give me a second here. Okay. No, I have to note it down, right? So just give me why I didn't get it. Print screen. What is the print screen? Print screen. Okay. So let me see. So this is the end. So scientific notation, you can again see the giga, tera. That's why they put it, which you already seen it before, right? 10 to the power, 10 to the power.
Yes, ma'am.
All are done. Go for break.
Thank you.
You're welcome, dear. Let me see what is next one.
Thank you, Miss.
You're welcome.
Thank you, thank you, thank you.
Let's see if we can learn a thing or two about significant figures, sometimes called significant digits. And the idea behind significant figures is to just make sure that when you do a big computation and you have a bunch of digits there, that you're not over representing the amount of precision that you had, that the result isn't more precise than the things that you actually
কথা বললাম আমার দিয়ে দেবে বলবো ইয়ে করতে বলবো 2 ঘন্টার মধ্যে 4 ঘন্টা কাট করলে 4 ঘন্টা কারণ আমি তারপর ওর সঙ্গে ইয়ে করবো অয়েল চেঞ্জ করতে হবে ব্রেক কাট করে যদি বলে পরে অনেক পর এটা তোমার মাথায় ক্যান্সার হয় দুটো না না আমি করবো করবো সেখান থেকে কিন্তু এখন আছে দিন চলো আমি কাটতে পারি
এখন একটু পরে বেরোবো, হ্যাঁ? বুঝছেন? ক্লাস নিয়ে নি? Everyone is back?
Yes, ma'am.
Okay. So I'm just going to show you a couple of math rules and you guys can practice as per that. You probably already know because probably Sign has already showed you what to do that. How to the simplify, convert to improper fraction. Like say do first if several ideas present. They're giving you several ideas how to do that. What is the best one? You can do that. So you know this is what is nominator and what is denominator means. One is the divide. So top one is called the nominator and bottom one is called the denominator, right? When there is the full number like 6, 2 by 5. So how you are going to easy it? So you have to multiply the denominator with the full number. So 6 times 5 and then these 2 is going to be additional. So 6 times 5 plus 2 is equal to 32 by 5. So this is kind of an example how to simplify it. So after it's converted, go to the fraction rules and follow them. Okay, so if you just again divide the 32 by 5, is going to come to 6, 2 by 5. This is when there is a whole number before the fraction. When you are going to add up couple of fractions, numbers, say for example 3 by 5 plus 1 by 5 or more. So what you are going to do, what is the common for the addition, what is the denominators are common is going to be the same value. So 5 and 5 denominators because it's going to be the divided by that number. This number is going to be divided by 5 and this number is going to be divided by 5. So denominator is going to be common, it's going to be the same. This is called the common denominator. So common denominator. And then we are going to the addition, you are going to add the 3 and the 1, the nominator. You are going to add the nominator. So 3 plus 1 is equal to 4. And the denominator is going to be the common one, so it's going to be the same. So 4 by 5. Here, this is the plus and this is the subtraction. 4 by 7 and 1 by 7. The denominator is common again. So there is nothing to do. So you are going to put the denominator 7. And then the top one, the nominator, you have to subtract from 4. You have to subtract 1. So even you subtract is going to be 3. So 3 by 7. Okay. What happened? This is the common denominator. If you doesn't have a common denominator, what you have to do? So 3 by 7 plus 2 by 5. So it's going to be multiplied by the other denominator, the top one with the other denominator, and same thing, 7 by 5, 7 by 5. So it's going to be 3 times 5 divided by 7 times 5 plus 2 times 7. This is going to be multiplied. This side is going to be multiplied with their denominator. And this side is going to be multiplied the other side denominator. So 3 is going to be multiplied by 5 and the 7 is going to be multiplied by 5. So 3 by 7. And the other side Then denominator for the other side is the 7. So you have to multiply 2 times 7 and the denominator also pi by 7 as these the denominators for both the starting fractions are not common. So it's going to come up 3 times 5 is equal to 15 by 35 plus 14 by 35. So ultimately it's going to be 29 by 35. So this is the addition and subtraction for the common denominator and the not common denominator or the different denominators. Is that clear? Multiply the top and bottom of the second fraction by the denominator and follow the above rules for the common denominator for both. This side, the left side is going to be multiplied both up and down with the other side denominator, and the same thing for the other side, it has to be on the right side. In this case it has to be multiplied both up and numerator and denominator by the denominator from the other side. So then you have to do the calculation. Is that okay? Clear? You have to do practice.
Yes, ma'am.
It has to do
Yes,
practice.
ma'am.
Yeah, you have to do the multiply. Multiply, what you are going to do? Multiply is common. You have to come top to top multiply and bottom to bottom multiply. Nominator to numerator multiply and denominator to denominator multiply. So 1 by 5 times 4 by 7. So 4 times 1, this is the nominator, right? 4 times 1 times 4 is equal to 4. And you are now multiplying the denominators. 5 times m is 35. So it's 4 by 35. Okay. So when it's kind of division, one side becomes up and down. So it becomes multiply when you do this. 2 by 5 divided by 2 by 3. Nowadays calculator does everything. So what in general you have to do before 2 by 5, then you have to multiply it by 3 by 2 is going to give you the 6 by 10. 3 because it's easy, because multiplication you can do multiplication from the nominator to nominator and denominator to denominator. So when you multiply it, it becomes easy. 3 times 2 is equal to 6 and 5 times 2 is equal to 10. So in case of division, you have to make a multiplication and change the order. Denominator is going to be the nominator and nominator is going to come down to the denominator side. So like signs, 3, you have to follow the sign. So 3 plus 5 plus is the addition. So it's equal to 8. When there is a minus sign, plus minus 3, how you are going to write it? You are adding 2 minus. So ultimately the sign is going to be the minus or subtraction side. So minus 6, this plus is you are only adding this minus and minus. Here you are adding plus and plus. There is no sign. So it's going to be the 8. There is no need. It's a positive. When there is a minus, you have to make it pointed out that is the minus sign. So minus 6 plus minus 3 is equal to give you the minus 9. So be careful when they are going to give you the calculation, they put these signs. You have to make sure you are exactly putting the sign what is going to be the result. It's like 7 plus 4. Oh, here, so not 7 plus minus 4. So when you subtract the 4.7, it's going to be 3, it's going to plus, right? 7, the positive is bigger than the minus 1. So 7 plus, you are subtracting from 7, the 4, the minus sign. So it's going to be 3. Here the same thing. Here you have the minus sign 6 and the positive is 11. 11 is bigger and positive 1. You are subtracting 6 from the 11. So ultimate result is plus 5. When you are subtracting the bigger minus 8 with the smaller positive one. So plus 2, you are subtracting plus 2 from minus 8. How it is going to be reduced something, but it's going to be till minus sign, minus 6. Okay? This is in your D2L. You guys can go through that and try to practice some more. When there is minus and minus, when there is two same sign, minus and minus, it's become positive. That is the rule. So ultimately, when there is 2 minus sign, 8 minus minus 3. So that means 8 plus 3 is equal to 11. Minus 2 minus 5, that means minus 2 plus minus 5 is equal to minus 7 when there is a plus sign. When there is nothing, minus 8 and minus 3 means 11 plus. Minus 7 minus minus 4 is going to be minus 7 plus. So these two are going to make it to positive. Okay, these two is going to 2 minus sign side by side is going to make positive. But if there is a plus sign in between, then it's going to be minus or plus depending upon your subtraction, like minus 7 minus minus 4. So these two became positive. Minus and minus, when they are sides sitting together, they become positive. So minus 7 plus 4 minus 3. Same thing when the multiplication, everything will be positive. Minus 5 times minus 3 is equal to 15. 4 times minus, when there is only one sign, minus is going to be minus. 8 by 4, there is no sign, means positive 2. Minus 10 divided by minus 2. Here there is again 2 minus. So it's going to be nullified. This minus is going to be discarded by the minus. So it's going to be 5. 6 divided by minus 3. Again, there is only one sign, minus. So the result is going to be minus 2. This table is in your system. So you can look at that and practice more. So it's a,
Ma'am, excuse me.
yeah.
Ma'am, can you send this one to in our email? Because in our end, we cannot download this one so that we can print it to have our own copy.
Whether I can download it, right?
Ma'am, down, you scroll down, there is a download in your bottom.
Yeah.
That one, ma'am. Yeah, that one.
Okay. Okay.
Okay, thank you, ma'am.
Okay. Let me see whether it is downloaded or not. Is that math rules?
Yeah, yes, ma'am, that one.
I'll send it to you.
Yes, ma'am. Thank you.
Mm-hmm.
It's more easy to understand.
No,
Yes,
sure,
thank you,
sure.
ma'am.
If you doesn't have it, I will send it. Okay.
Perfect.
Let
Thank
me
you,
also,
ma'am.
okay, just let me do one thing also. Team. Go to files. Then I can copy the link. Sent. Okay.
Yes, ma'am. Thank you so much.
Thank you, ma'am.
I send you another one for your practice also. So under the same email, maybe you can see two of them.
Okay.
Okay.
Thank
so
you, ma'am.
number
Okay.
one, this one, and student bed mass decimal fraction exercise. Okay. I'll send this one, and this is the math rules. Both of them are sent. Okay.
Okay, thank
Okay.
you.
Okay, ma'am. Thanks.
Welcome. No problem. So this is the wrong answers. Okay. So where we are? Yeah. Math rules. Okay. So this I send you, so you can just have a look, practice, try to figure out different numbers, and then you can do that one. Okay. Next is probably we have something rounding significant numbers. This has already has done. This is nothing to do too much. We already did this one, okay? So now you have seen this video.
No, ma'am.
Sorry, no sound.
Yes, ma'am. No sound.
No sound? How come I did the sound?
Let's see if we
Can you hear now?
to about significant.
Can you hear now?
Significant
Yes, ma'am.
figures, sometimes called
Okay.
significant digits.
Yes,
And the
miss, we
idea
can hear you.
behind significant figures is to just make sure that when you do a big computation and you have a bunch of digits there, that you're not over representing the amount of precision that you had, that the result isn't more precise than the things that you actually measured that you usually use to get that result. But before we go into the depths of it and how you use it with computation, let's just do a bunch of examples of identifying significant figures. And then we'll try to come up with some rules of thumb. But the general way to think about it is which digits are really giving me information about how precise my measurement is. So on this first thing right over here, the significant figures are this 700. So over here you have three significant figures. And it might make you a little uncomfortable that we're not including these zeros that are after the decimal point and before this 7, that we're not including those because it's like, that does help define the number. And that is true, but it's not telling us how precise our measurement is. And to try to understand this a little bit better, imagine if this right over here was a measurement of kilometers. So if we measured 0.00700 kilometers, that same measurement, this would be the exact same thing as 7.00 meters. Maybe, in fact, we just used a meter stick and we said it's exactly 7.00 meters. So we measured to the nearest centimeter. And we just felt like writing it in kilometers. These two numbers are the exact same thing. They're just different units. But I think when you look over here, it makes a lot more sense why you only have 3 significant figures. These zeros are just kind of telling you, are just shifting it based on maybe what the units of measurement that you're using. But the numbers that are really giving you the precision are the 7, the 0, and the 0. And the reason why we're counting these trailing zeros is that whoever wrote this number didn't have to write them down. They wrote them down to explicitly say, look, I measured this far. If they didn't measure this far, they would have just left these zeros off and they would have just told you 7 meters, not 7.00. Let's do the next one. So based on the same idea, we have the 5 and the 2. The non-zero digits are going to be significant figures. You don't include this leading 0 by the same logic that if this was 0.052 kilometers, this would be the same thing as 52 meters, which clearly only has two significant figures. So you don't want to count leading zeros that are leading zeros before the first non-zero digit, I guess we could say. You don't want to include those. You just want to include all the non-zero digits and everything in between, and trailing zeros if a decimal point is involved. I'll make those ideas a little bit more formal. So over here, the person did 370 and then they wrote the decimal point. If they didn't write the decimal point, it would be a little unclear on how precise this was. But because they wrote the decimal point, it means that they measured it exactly to be 370. They didn't get 372 and then round down, or they didn't have kind of a roughness only to the nearest tens place. This decimal tells you that all three of these are significant. So this is three significant figures over here. Then on this next one, once again, this decimal tells us that not only did we get to the nearest 1, but then we put another trailing 0 here, which means we got to the nearest 10th. So in this situation, once again, we have 3 significant figures. Over here, the 7 is in the hundreds, but we got all the way down. The measurement went all the way down to the thousandths place. And even though there are zeros in between, those zeros are part of our measurement because they are in between non-zero digits. So in this situation, every digit here, the way it's written, is a significant digit. So you have 6 significant digits. Now this last one is ambiguous. The 37,000. It's not clear whether you measured exactly 37,000. Maybe you measured to the nearest 1 and you got an exact number. You got exactly 37,000. Or maybe you only measured to the nearest 1,000. So it depends on what, there's a little bit of ambiguity here. If you just see something written exactly like this, you would probably say, if you had to guess, or not guess, if there wasn't any more information, you would say that there's just 2 significant digits. 2 significant figures or significant digits. For this person to be less ambiguous, they would want to put a decimal point right over there, and that lets you know that this is actually 5 digits of precision, that we actually go to 5 significant figures. So if you don't see that decimal point, I would go with 2. Now that we have a decent understanding of how to figure out how many significant figures we're even dealing with, let's think about a situation where significant figures will or might become irrelevant. So let's say that I have a carpet here, and using maybe a meter stick, I'm able to measure the carpet to the nearest centimeter. And so I get the carpet to the nearest centimeter, I get it to being 1.69 meters. So this 9, obviously this is to the nearest centimeter. This 9/100ths of a meter is the same thing as 9 centimeters. And let's say I'm able to measure the width here as 2.09 meters. I use the same meter stick. And you were to ask me, Sal, what is the area of your carpet? And so, I'd just do the straight up calculation. The area is just going to be the length times the width. So it would be 1.69 meters times 2.09 meters, 2.09 meters. And we could do this by hand, but let me just get the calculator out just to make things move along a little bit faster. And so we have 1.69 times 2.09, and that gives us 3.5321. Let me write that down. 3.5321. So let me write this in a new color. So this gives us 3.5321, and we have a meters times a meters, which gives us meters squared, or square meters. And so I might very proudly tell you, hey, the area here is 3.5321 square meters. And the problem here is that when I give you this thing that has, all of these numbers behind the decimal point and all of these what we now know to be significant figures, it implies that I had a really precise way of measuring the area. Well, in reality, I only was able to measure the area to the nearest centimeter. So the way we would do this, so that I don't make it look like my measurement is more precise than it really is, or this calculation that's derived from my measurements, I make sure that it has no more significant figures than either of the numbers that I multiplied. So in this situation, I have 3 significant figures here, 3 significant figures. And over here, I have 3 significant figures, 3 significant figures. And so in general, when you multiply or divide, the significant figures in your product or the product, or I always forget, there's the divisor, there's the dividend, and there's the quotient. The quotient, the numbers, the significant figures in your product or your quotient cannot be any more than the least number of significant digits in whatever you are using to come up with that product or quotient. So over here, both of these have 3 significant figures, so I can only have 3 significant figures in my product. If this had 3 significant figures and this had 2 significant figures, I could only have 2 significant figures in my product. So in order to be kind of legit here, I have to round this to 3 significant figures. So I have to round it to 3 significant figures, and so I'm going to round to the nearest hundredth here. And so this 2 will round down. So this gets us to 3.53 meters squared. And now we're cool with the significant figures. Let's do another situation with division. Let's say that I'm laying tiles down in my bathroom. And so the diagram will look very similar. And I measure the width of my bathroom to be, let's say it is 10, I'll do it in feet now. So let's say it is 10.1 feet. And this is the precision that I'm able to measure it with. So I'm able to measure it to the nearest tenth of a foot. And let's say that the length of my floor, is, let's say the length of my floor, I'll just make up a number, is 12 and so for whatever reason, I was able to measure this with slightly higher precision. So 12.07 feet. And let's say that I have tiles. And the tile has an area. So someone else measured it for me. It has an area of, let's say that the area of this tile is 1.07 feet squared. And this was just measured for me. And what I want to do is I want to figure out how many tiles can fit on this bathroom floor. So what I would do is I would figure out the area of this bathroom floor and then divide by the area of the tiles. And so the area of the bathroom floor, so floor area is going to be equal to 10.1 feet times 12.07 feet. And so that will give us, let's calculate it. It is 10.1 times 12.07 feet. So it gives us 121.907. 121.907. So this is equal to, let me scroll over a little bit to the right. This is equal to, I can do a little bit more to the right. This is equal to 121.907 feet squared, or square feet. Now, we're not done with our calculation, but there might be a temptation right here to say, look, I had 4 significant figures over here. I have 3 significant figures over here. There would be a temptation to say, look, my area should not have more than 3 significant figures. And that temptation would be okay if this is all you were looking for, if the final answer you were looking for was the area of the floor. But we're not done with our calculation. We want to figure out how many of these tiles will fit into this area. And so the general rule of thumb, because you don't want to lose information, the general rule of thumb is don't round to significant figures until you are done with your calculation. Until you are done, especially if you're just doing a bunch of multiplying and dividing. Because otherwise, if you round here, you actually will introduce more error into your calculation than you'd want to. So what you do is you keep it as kind of the full number. Now you do the division. So let's do the division. So the tiles per floor, the tiles per, I guess we could say my bathroom, or tiles in the bathroom, tiles fitting in bathroom, in the floor of this bathroom. It would be the area of the bathroom, so 121.907 feet squared, divided by the area of the tile, divided by 1.07 feet squared. And once again, let me get the calculator out. And so we have 121.907 divided by 1.07, and you get this crazy thing with all of these digits, but this is going to be our final answer. So here we do care about significant figures. So tiles fitting in the bathroom, we get something that actually just keeps going. So it's, let me write this in a new color. We get 113.931775701, and it actually just keeps going. feet squared. And since this is the final answer, we care about how many tiles will fit onto this bathroom floor. Now the significant figures come into play. And the way to think about this is I have 4 significant figures over here. I have 2 significant figures over here. I have 3 significant figures over here. And since we did just a bunch of multiplying and dividing, and in general, well, since we did a bunch of multiplying and dividing, we have to have the minimum, whatever is the minimum significant figures of the things that we computed with, that's how many significant figures we can have in our final answer. Oh, let me make this clear. This isn't 2 significant figures. This is 3, the 1, the 0, and the 1. So our final answer can only have 3 significant figures. 3 significant figures. So we need to round to the nearest foot. The next digit over is a 9, so we're going to round up. So we're going to round up. So this will get us to 114. Actually, the units here aren't in square feet. This is in tiles. This is feet divided by feet. And so this is going to be 114 tiles. Obviously, it's not going to be exactly 114 tiles, but based on the precision of the measurements we've done, we can say 114 tiles. Now, what I've just showed you right here is when we multiply and divide measurements that have a certain number of significant figures. The general rule of thumb is whatever is the minimum number of significant figures and any of the numbers are calculated, that's how many significant figures, or I guess the least number is the number of significant figures in your final quotient or product or answer. When you do addition and subtraction, it's a little bit different, and we'll cover that in the next video. We saw in the last video that when you multiply or you divide numbers, or I guess we should say when we multiply or divide measurements, your result can only have as many significant digits as the thing with the smallest significant digits that you ended up multiplying and dividing. So just as a quick example, if I have 2.00 times, I don't know, 3.5, my answer over here can only have 2 significant digits. This has 2 significant digits. This has 3. 2 times 3.5 is 7. And we can get to one level, we can go 1 0 to the right of the decimal because we can have 2 significant digits. This was 3, this is 2. We only limit it to 2 because that was the smallest number of significant digits we had in all of the things that we were taking the product of. When we do addition and subtraction, it's a little bit different. And I'll do an example first. I'll just do kind of a numeric example first, and then we'll think of a little bit more of a real-world example. And obviously, even my real-world examples aren't really real-world. In the last video, I talked about laying down carpet, and someone rightfully pointed out, hey, if you're laying down carpet, you always want to round up, just because you don't want to, it's easier to cut carpet away than to have to somehow glue carpet there. But that's a particular to carpet. I was just saying a general way to think about precision and significant figures. But that was particular only to maybe carpets or tiles. But when you add or subtract, now the significant digits or the significant figures don't matter as much as the actual precision of the things that you're adding. How many decimal places do you go? So for example, if I were to add 1.26 and I were to add it to, let's say I were to add it to 2.3, if you just add these two numbers up, and let's say these are measurements. So when you make it, this is clearly 3 significant digits. We were able to measure to the nearest hundredth. Here, this is 2 significant digits. So 3 significant digits. This is 2 significant digits. We're able to measure to the nearest tenth. Let me label this. This is the hundredth. This is the tenth. When you add or subtract numbers, your answer. So if we just do this, if we just add these two numbers, I get what? I get 3.56. The sum or the difference, whatever you take, you don't count significant figures. So you don't say, hey, this can only have 2 significant figures. What you say is this can only be as precise as the least precise thing that I ever had over here. The least precise thing I had over here was 2.3. It only went to the tenths place. So in our answer, we can only go to the tenths place. So we need to round this. We need to round this guy up because we have a 6 right here. So you round up. So if you care about significant figures, this is going to become a 3.7. And I want to be clear, this time it worked out because this also has 2 significant figures. This has 2 significant figures. But this could have been, let me do another situation. You could have 1.26 plus 102.3. And then you would get, obviously, you would get 103.56. And in this situation, this obviously over here has 4 significant figures. This over here has 3 significant figures. But in our answer, we don't want to have 3 significant figures. We want to be only as precise as the least precise thing that we added up. The least precise thing, we only go 1 digit behind the decimal over here. So we can only go to the tenths, only 1 digit behind the decimal there. So once again, we round up to 103.6. And to see why that makes sense, let's do a little bit of an example here with actually measuring something. So let's say I have a block here. Let's say that I have a block. Let me draw that block a little bit neater. And let's say we have a pretty good meter stick, and we're able to measure it to the nearest centimeter, and we get it. It is 2.09 meters. And let's say we have another block. Let's say we have another block, and this is the other block right over there, and we have a, let's say we have even a more precise meter stick that can measure to the nearest millimeter, and we get this to be 1.901 meters. So we're measuring to the nearest millimeter. And let's say that those measurements were done a long time ago and we don't have access to measure them anymore, but someone says, how tall is it if I were to stack the blue block on top of the red block or the orange block or whatever color that is? So how high would this height be? Well, if you didn't care about significant figures or precision, you would literally just add them up. You would add the 1.901 plus the 2.09. So let me add those up. So if you take 1.901 and add that to 2.09, you get 1 plus nothing is 1. 0 plus 9 is 9. 9 plus 0 is 9. You get the decimal point. 1 plus 2 is 3. So you would get 3.991. And the problem with this, the reason why this is a little bit, it's kind of misrepresenting how precise your measurement is that you don't know. If I told you that the tower is 3.991 meters tall, I'm implying that I somehow was able to measure the entire tower to the nearest millimeter. The reality is I was only able to measure part of the tower to the nearest millimeter. This part of the tower I was only able to measure to the nearest centimeter. So to make it clear that our measurement is only good to the nearest centimeter, because there's more error here than, it might overwhelm whatever precision we had on the millimeters there. To make that clear, we need to make this only as precise as the least precise thing that we're adding up. So over here, the least precise thing was we went to the hundredths. So over here, we have to round to the hundredths. And since 1 is less than 5, we're going to round down. And so we can only legitimately say, if we want to represent what we did properly, that the tower is 3.99 meters. And I also want to make it clear that this doesn't just apply to when there's a decimal point. If I were to tell you that, let's say I were to measure a building, and I was only able to measure the building to the nearest 10 feet. So I tell you that that building is 350 feet tall. So this is the building. This is a building. And let's say that there's a manufacturer of radio antennas. Or radio towers. And the manufacturer has measured their tower to the nearest foot. And they say that their tower is 8 feet tall. So notice, here they measured to the nearest 10 feet. Here they measured to the nearest foot. And actually, to make it clear, because once again, as I said, this is ambiguous. It's not 100% clear how many significant figures there are. Maybe it was exactly 350 feet, or maybe they just rounded to the nearest 10 feet. So a better way to represent this would be to say, instead of writing it 350, a better way to write it would be 3.5 times 10 to the second feet tall. And when you write it in scientific notation, it makes it very clear that there's only 2 significant digits here. You only measured to the nearest 10 feet. Other ways to represent it, you could write 350. This notation is done less, but sometimes the last significant digit has a line on top of it, or the last significant digit has a line below it. So either of those are ways to specify it. This is probably the least ambiguous. But assuming that they only measured to the nearest 10 feet, and someone would ask you, how tall is the building plus the tower? Well, your first reaction would let's just add the 350 plus 8. You would get 358. You would get 358 feet. So this is the building plus the tower is 358 feet. But once again, we're misrepresenting it. We're making it look like we were able to measure the combination to the nearest foot. Well, we were only able to measure the tower to the nearest foot. So in order to represent our measurement at the level of precision that we really did, we really have to round this to the nearest 10 feet because that was our least precise measurement. So we would really have to round this up. 8 is greater than or equal to 5, so we'll round this up to 360 feet. So once again, whatever is, and just to make it clear, and once even this is ambiguous, maybe we put a line over it to show that that is our level of precision, that we only have 2 significant digits, or we could write this as 3.6 times 10 to the second, which is just 100, 3.6 times 10 to the second feet in scientific notation. And this makes it very clear that we only have 2 significant digits here.
No offense, but if you still think stocks, real estate, or crypto are the best passive income investments in today's economy, I'm sorry, but you've got it wrong. There's a little known trend attracting millions of dollars a day right now called Audible uploads. Audible, owned by Amazon, is one of the biggest sources of audiobooks and podcasts in the world.
Let me go to the witness again. Video. Order of operation. We did this one, right?
Hi, and welcome to Math Antics. Today we're going to talk about an important math concept called order of operations. Order of operations is just a set of math rules that tell you which math operations, like addition or multiplication, to do first. Now you might be wondering, especially if you're a teenager, why do I need rules to tell me which operations to do first? Can't I just do them in any order I want? Well, that's a really good question. And to answer it, we're going to give 2 totally different people the same math problem to solve. The problem is 2 plus 5 times 4. I like addition better than multiplication, so I'm going to do that first. Let's see, 2 plus 5 gives us 7, and then I just multiply that 7 by the 4, and I get 28. That was easy, but you'd better not copy my answer. Don't worry, I'm not going to copy your answer because I want the right answer. And I prefer multiplying, so I'm going to do that first. Let's see, 4 times 5 equals 20, and then I'll add the 2, which gives me 22 for a final answer. What makes you think that's the right answer? All my calculations were correct. I even checked it with a calculator. The only calculator I need is right up here. And the correct answer is boop, 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 22. Okay, so which one of these guys do you think is right? Neither one made any mistakes with the calculations. They just did the operations in a different order and got different answers. Well, since there were no mistakes, in a way they were both right. But math would be a very confusing subject if there were different answers to the same problem. And that's where order of operations can help us out. The order of operations rules are a way for us all to agree on the order that you should do math operations in. And if we always do operations in the same order, then we'll always get the same answer. So now that you know why we need order of operations rules, let's find out what those rules are. There are basically 4 of them, and they go something like this. First, do operations in parentheses and brackets. Next, do exponents. Then, do multiplication and division. Last, do addition and subtraction. Let's take a closer look at each of these rules and see some examples where they help us. First on the list was do operations in parentheses and brackets. Now, in case you haven't seen parentheses or brackets used in math before, let me briefly explain how they work. Parentheses are just these symbols that curve forwards and backwards, and they're used in pairs like this. And when we put numbers and operators in between them, it forms a group. It's almost like the parentheses form a package to hold whatever math stuff we put inside them. And brackets work exactly the same way as parentheses. They just have a different shape that looks a little more boxy, but they mean exactly the same thing. So parentheses and brackets are used to group things together, and our rules tell us to do any operations inside these groups first. For example, have a look at this problem. 10 times 4 plus 5. It has 3 numbers and 2 operations, multiplication and addition. But 2 of the numbers and the addition symbol are inside parentheses. That means that they form a group, and we need to do that part of the problem first. 4 plus 5 equals 9. So the part inside the parentheses can just be replaced with the simplified value 9. Oh, and once you do the math that's inside parentheses and get a single number like this, you usually don't need to show the parentheses anymore. Now that the parentheses are gone, we just have one operation left to do. We multiply 10 times 9, and that gives us 90 as our final answer. So parentheses can really help you know what part of a problem you're supposed to do first. But what if you get a problem that has more than one set of parentheses, like this? 5 minus 3 plus 6 times 2. Fortunately, it doesn't matter which set of parentheses you do first. You just need to do everything that's inside the parentheses before you do anything that's not inside parentheses. In other words, we need to simplify both of our parentheses groups before we can do the addition in between them. The first group, 5 minus 3, simplifies to 2. And the second group, 6 times 2, simplifies to 12. Now we can do the last operation and add the values that we got from simplifying. 2 plus 12 equals 14. Okay, now that we know that we always do operations in parentheses or brackets first, let's take a closer look at the second rule that says the next thing we do is exponents. Now, if you haven't seen exponents before, they're just a way of writing repeated multiplication. For example, the repeated multiplication 4 times 4 can be written in a shorter form as 4 multiplied twice. And 4 times 4 times 4 can be written as 4 multiplied 3 times. And 4 times 4 times 4 times 4 can be written as 4 multiplied 4 times. Get the idea? This small number is called an exponent, or power. It just tells you how many times to multiply the bigger number together. So after we take care of any parentheses, simplifying any exponents becomes the next highest priority. For example, in this problem, we have to simplify the exponent before we can do the other multiplication. The exponent is telling us to multiply 5 together twice. So 5 times 5 is 25. And after we do that, then we multiply the result by 3. So 25 times 3 is 75. Oh, and one thing I should point out, sometimes you'll get a problem that has exponents inside of parentheses, like this problem. And you may wonder, how can I get rid of the parentheses before I do the exponents? You might think that if you simplify the exponent first, you're breaking the rules. But the truth is that by doing whatever operations are inside the parentheses, you are doing the parentheses first. The parentheses really just tell you where to start. So in this problem, first we do 3 to the power of 2, which means 3 times 3, which is 9. Then the part inside the parentheses is 9 times 4, which equals 36. And once the parentheses are gone, we add 36 plus 6 and get 42 as our final answer. All right, now we're going to look at the last two rules together. These two rules are really important because they deal with the most common math operations: addition, subtraction, multiplication, and division. And the rules tell us that we need to do multiplication and division before we do addition and subtraction. To see how these rules work, let's look at a few quick examples that use those basic operations. First, let's try this one. 2 plus 5 times 4. Aha! Does this look familiar? Yep, it's the one we gave to my two friends earlier. And now that we have our rules, we see that we have to do the multiplication before the addition. 5 times 4 equals 20, and then we add the 2, which gives us 22. So the second guy was right. What a surprise! Now let's try this one. 3 times 5 minus 1. Our rules tell us that multiplication is higher on the list than subtraction, so we do 3 times 5 first. And that gives us 15, and then we subtract the 1, which leaves 14 as our final answer. Here's one with division and subtraction. 20 minus 10 divided by 5. And since division has a higher priority, we do the 10 divided by 5 first, which equals 2. And then we subtract 2 from 20 and get 18 as our final answer. And here's another problem. 12 divided by 6 plus 5. Again, our rules say to do the division before addition. So 12 divided by 6 equals 2, and then we add the 5 to get 7. And here's one last problem. 40 divided by 4 times 5. Which do we do first, the multiplication or division? Our rules don't tell us. Well, that's because multiplication and division are tied for priority or importance. So are addition and subtraction. And that's the reason we need an extra part at the end of each of these rules that says from left to right. If you have a problem that has both multiplication and division, then you're supposed to work it from left to right. That's because in some cases, you can get a different answer if you go from right to left. For example, in this problem, if you work from right to left the wrong way, you would do the 4 times 5 first and get 20. And then 40 divided by 20 equals 2. But if you go from left to right, you would do 40 divided by 4 first, which is 10. And then 10 times 5 equals 50. Wow, the direction we went made a big difference. So whenever you have a problem that has a mixture of multiplication and division, or a mixture of addition and subtraction, you know to do the operations in order from left to right. All right, we're just about done, but let's have one more look at all 4 of our rules before you start practicing with the exercises. The order of operations rules say, first, do operations in parentheses and brackets. Next, do exponents. Then, do multiplication and division from left to right. Last, do addition and subtraction from left to right. All right, that does it for this video. Good luck with the exercises, and I'll see you next time. Learn more at mathantics.com.
Let's see if we can learn a thing or two about significant.
Okay, so what is the next one? Now, bed mass. You have already seen the bed mass. Now you guys know what to do, right? And this one I send you by email to do this one. So you know what is coming, which one, first and last, okay? What is going to be in the... So this is the bed mass, everything. So you can practice this one. Already sent. What is the next one? So this is also the practice. So I'm going to download it integers. 4 plus minus 7. What is going to be the value of this one? 4 plus minus 7?
Minus 3.
Minus
Minus
3.
3, yes.
Minus 3 minus 6.
3.
Minus 9.
3.
No.
Minus
What
9.
I told you, when there are 2 minus, it becomes positive. There is a minus,
Yeah.
there is a minus.
It's
So it's going to be
minus 9.
Minus 9, ma'am.
Minus 9.
minus
It's
1
3.
times 9 is only
gonna
3. Yeah.
3,
So
yeah.
what is
3.
minus 1 times 9?
Minus 9.
Minus 9.
9. So you guys can practice this one. You guys can download this one, or I have to send it.
Ma'am, Miss
No,
Shanina
I think,
print it for us.
we
We
have
already
this
have
one.
the copy.
She printed for
Yes,
us.
ma'am.
She already printed for you? So you have the
Yes,
copy?
ma'am.
Okay, so we don't need this one then. Okay, you already did it. Okay, good.
Yeah, Miss, can I go now, please?
Yes,
I'll
ma'am.
be still on team. Thank you.
This one she already did that? Percentage?
Yeah. Yes,
See,
ma'am.
this is also you have, right? Common fraction. Okay, so you are covered. Bit mass. Okay. This is the answer key. Forget it. Okay, so this one she already did also then. Rounding.
Yes. Yes, ma'am.
Okay, so you have all this. You have to practice all these things. This one also, probably, right? This is the answer key, so forget it. So this one we did. So this one, did we show the video?
Hey, you have an hour this week, right? Yeah. Great. I can teach you how to play 100 songs on piano in an hour. No way. All you need to learn is 4 chords. These. 1.
In today's video, we're going to look at how you add and subtract
You
fractions.
guys know that? You want what to watch
there
the
are really
video, or
2 key
I can
points
skip
you need to
it?
know. The first is that you
No,
have
ma'am,
to
let's
have a
watch it,
common
ma'am.
denominator.
Thank you.
Okay.
I'm
Okay.
still
Means
quite
that the
confused with
numbers on the
that.
bottom of your
Okay.
fractions need
Yeah,
to be
me
the same.
too.
Okay.
And the second is that you only add or subtract the numerators, which are the numbers on top. So in this sum here, where we're trying to add 3/4 and 1/3, the first thing we need to do is find a common denominator, which means that we need to make these two denominators the same number. The best way to do this is to find their lowest common multiple, or LCM, which is the smallest multiple that they both have in common. And so in this case, that's going to be 12. Now that we have the LCM, we can rewrite the equation, but with both of our denominators as the number 12. Then, because we've changed the denominators of our fractions, we're going to have to figure out what the new numerators will be. To get from 4 to 12, we've effectively multiplied it by 3. So we're also going to have to multiply the numerator of 3 by 3 as well, to get 9. This means that we've changed the 3/4 into 9/12. But that's absolutely fine, because they're both exactly the same value. 3/4 is just a more simplified version. Then for this other one, to get from 3 to 12, we've multiplied it by 4. So we also need to multiply the 1 by 4 to get a new numerator of 4. And again, because we multiplied the numerator and the denominator by the same number, 1/3 and 4/12 both have exactly the same value. Now that we've done the tricky part of getting a common denominator, all we have left is the easy part of adding the numerators together. So 9 plus 4, which gives us 13. And because we don't change the denominator, it'll be 13 over 12. And then it's always good to double check if your fraction can be simplified. But 13 over 12 can't. So we leave that as our final answer. Now let's take a look at this subtraction question, where we've got to subtract 2/5 from 5/3. Like before, the first step is to find a common denominator, which we do by finding the lowest common multiple of 3 and 5, which is 15. So we go ahead and rewrite our fractions with 15 on the bottom and figure out what the new numerators will be. To get 15, we have to multiply 3 by 5. So we also have to multiply 5 by 5 to get 25. And to get from 5 to 15, we've multiplied by 3. So we also multiply 2 by 3 to get 6. Then lastly, as we only subtract the numerators, we do 25 take away 6 to get 19 over 15. And again, we can't simplify that at all, so we leave that as our final answer. In case you didn't notice, 5/3 is an improper fraction, because the numerator is bigger than the denominator. But this doesn't matter at all when you're adding or subtracting fractions. We just treat it like any other fraction. If we'd been given it in a mixed number form though, so 1 and 2/3, then we'd have needed to convert it into its improper fraction form first. Let's have a go at a couple more examples. So in this first one, we're trying to add 2 and 3/4, which is a mixed number, to 5/12. The first step is to convert 2 and 3/4 to its improper fraction form, which we do by multiplying the 2 by the denominator of 4 to get 8, and then adding that 8 to the numerator of 3, so that we get rid of the 2 and just have 11 over 4.
Subtract.
Next, we need to find a common denominator. So we find the lowest common multiple of 4 and 12, which is 12, and then rewrite the question. To get from 4 to 12, we have to multiply by 3. So we also multiply the 11 by 3 to get 33 over 12. 5/12 already has a denominator of 12 though, so we don't need to do anything to that one, and we can just rewrite 5 over 12. Then last, we just add the numerators together. So 33 plus 5, giving us 38 over 12. which we can simplify down to 19 over 6. In this last one, we're doing 5/6 minus 4 over 15. The lowest common multiple of 6 and 15 is 30. To get from 6 to 30, we have to multiply by 5. So we also multiply the 5 by 5 to get 25. To get from 15 to 30, we multiply by 2. So we also multiply 4 by 2 to get 8. Then by subtracting the numerators, we get 25 minus 8 to end up with 17 over 30. Anyways, that's everything for this video. So if you had any thoughts, then please do let us know down in the comments. And cheers for watching.
Why become a My Way student ambassador?
Did this one or the another
In
one?
this video, we're going to look at how you multiply and divide fractions.
This one we did, right? Yes,
Now,
sir.
multiplying fractions is actually
So
fairly
we did
easy.
this right now. Okay. What is the next then? Oh, what is coming?
In this video, we're going to cover how to convert terminating decimals into fractions. Or in exams, they'll often ask you to express the terminating decimal as a fraction. Now, a terminating decimal is just a decimal that has a limited number of decimal places, like 0.7 or 0.031. So they're the ones that don't go on forever. To convert them into a fraction, though, like if we were asked to express 0.7 as a fraction, there's a couple steps that we have to do. The first thing we have to do is take all the digits that are to the right of the decimal point, so 7 in this case, and make those digits the numerator of our fraction. Then for the denominator, we start by writing a 1, and then we have to work out how many zeros we have to add after that 1. And the point to remember is that the number of zeros we use is exactly the same as the number of digits we have after the decimal point. So here, with 0.7, we have just the 7 after the decimal point, so 1 digit. And that means we're going to put a single 0 after our 1, making our denominator 10. So our fraction is just 7 over 10. Similarly, if we were asked to express 0.13 as a fraction, we'd start by taking that 13 and making it the numerator of a fraction. Then we'd put a 1 on the bottom and think about how many zeros we need to add to it. And because there are only 2 digits after the decimal point, the 1 and the 3, we're going to have to add 2 zeros so that we get 13 over 100 as our fraction. As a slightly harder one, let's try to express 0.031 as a fraction. The first thing we're going to do is take all the digits after the decimal point, so 031, and put that as our numerator. This time though, we can get rid of the 0 and just write it as 31, because it's exactly the same thing. Then, like always, we put a 1 as our denominator and work out how many zeros we need to add. 0.031 has 3 digits after the decimal point, the 0, the 3, and the 1. So we're going to have to add 3 zeros to the 1 in our denominator, giving us 31 over 1000 as our answer. And we're done. Anyway, that's everything for this video. So I hope that all made sense. If you enjoyed it, then
So this you have to do the pediatric calculations like pound to kg, and this is going to come in your question. A child It's a glucose tolerant test and needs less than usual adult dose, obviously. Calculate how to make a glucose drink to the correct dose for a child who is 60 pounds as guided by the following. So correct child dose, it needs 1.5 gram glucose per kg of body weight, which is going to be stirred into 250 ml of tap water. So you have to convert it first. 60 pound is how much kg, because it's give to the expression in the gram, right? So you have to convert into the how much pound is equal to kg, and 1.5 gram is the baby body weight is 27 kg, and it says 1.5 glucose per kg of the body weight. So body weight is 27 kg. So how much we need? 27 times 1.5 gram is equal to 40 gram, right? Per kg of body weight, we need 1.5 gram of glucose. So baby's body weight at the beginning, it is calculated 60 pound, which we have converted to kg. So baby's body weight or the child's body weight is 27 kg. Now we need 1.5 gram glucose per kg. How many kg has the child has? 27 kg. So we need total 1.5 times 27 is to 40 gram of glucose. And then they told it have to mix it in 250 ml. So you have to weigh 40 gram of glucose into 250 ml of tap water or whatever drinking water. So then they are giving you a couple of examples. You are preparing a lactose drink to perform a lactose tolerance test for a child who is 45 pounds. The formula used for such a preparation is 1 gram per 1 kg body weight. How many grams are needed to be dissolved to prepare the drink for this child? So you guys have to do all these things. You can print it out or download, or she already give it to you.
No, ma'am. Ma'am, are we going to submit that?
Yes, you have to submit it probably.
Okay.
Does it say it, right? Yeah. You have that in your, sorry. Do you have
No,
that one?
we don't have the printout yet, ma'am.
Okay. So you want me to download and give it to you?
Yes, please, ma'am. Thank you.
Yes, miss.
You doesn't have in your things in the D12?
No, ma'am, we cannot download.
Okay. Try to practice by yourself. There may be answer key, but just try to do by yourself. Then it's going to be easy. You guys can understand what is happening. Okay, now download. There's okay. How many units I have for this one? First and second is that. Third and fourth. 5, 6, 7, 8. Okay. So we have tomorrow, day after tomorrow. So you can go 3 days in preparation, 4 days in preparation calculation. Monday 5 and 6. We'll see how much. When you're going to do the exam, that's also another thing. When you're going to do the exam, in the weekdays, in the lab. Tuesday we are going to be online. So when you are going to do that on Wednesday, sorry, do the exam in the lab on the campus next Wednesday. Oh, Friday. Hello.
Friday will be good, ma'am. Thank you.
Friday, so you can do
Yeah.
that on campus, okay? You do the
Yes.
exam and then we follow up with the things. Okay, so Friday we have time then. Okay.
No. No, don't scare.
Only
Next
for
Friday
you,
on
only for,
don't
campus.
scare us.
only for you, Louis, this Friday, okay? Only for you.
Yeah.
Only for you. I will make a special question for Louis. What? You want to do it? It's this Friday. You tell this Friday you are ready for this Friday.
Yeah. Because we
Okay.
can still ask you, ma'am, in lab if we have some confusion.
Ma'am, I have question.
Who is that?
It's in home.
Yes, Young. Tell me.
Yeah, ma'am. Yeah. It's on the practice question. One of the practice the sheet you showed yesterday the China.
I don't know which one she showed to you.
You should just you just should as also the question that the minus about minus plus.
Yes, that's right, Young
There's
Hong.
one simple vision hack anyone
This
can
one?
use to improve.
My answer is 3, but some answer is -9.
And we have the answers already. It's -9. So that's
You
a
have
really
already
big
have the answers.
difference.
How you did that? Yeah, it's going to minus is going to give the answer. So this is the formula. This I send it to you. You had this one? Type of fraction.
But ma'am, based the math rulers at the subtract part, the 2 minus treat as positive. That's why I don't understand.
I have to see the.
Can you please check the math rules on subtract part?
Math rules. Okay, let us go to the math rules.
Yeah, the math rule subtract. The example is -7 minus -4. That's -3.
This is the math rule.
Yeah, on the subtract part.
That's I'm looking. This is the subtraction part.
Yeah. So have an example is -7 minus -4.
Where you are seeing -7, -4?
It's in the subtract part, the integers.
Yeah.
Integers down. Okay, so
Yeah,
it's not on
yes,
the
ma'am.
substrate part. Okay. 100%. Okay.
So the answer
This
is
here.
minus. Yeah.
Here.
Yeah.
You are talking this one? You are
No,
talking
ma'am.
this
Go
one?
No,
down a
go
little
down.
bit.
Go down.
That one.
Yeah, that one. Yeah.
So why? You said that when there are 2 minus, it's going to be the plus.
Yes.
So that's why it became plus. -7 plus 4 is equal to -3.
Yeah, so based according to this rule, the answer should be 3, not
Yes.
-9.
Not minus. Its answer should be -3 because 7 is still minus is the bigger value.
Yeah.
Yeah. And so we have the question on the practice sheet.
Okay, so what
Yeah.
is the practice sheet now? I can go back and forth. What is the practice? Did I send you the practice sheet? That's why?
Yes, ma'am. We
Yes,
have it.
ma'am.
Okay.
We have.
Okay, so practice sheet, go to my files. Okay. Close, okay. What is the practice sheet? This one? Bidmas, decimals? This one? Which one?
The other one.
Integers, ma'am.
Integers.
Practice exercise integers.
Did I send it to you, that one?
Ma'am,
Yes, ma'am.
Shaina print that one for us.
We have a
So we have
copy.
our copy.
You have your own copy?
Yes,
Yes,
ma'am.
ma'am.
I am not sending it to you.
No, ma'am.
Okay, so I have to know which is the sheet. I cannot tell from here. What is the sheet you have?
Mom, you just showed us and we answered.
I know, but I showed you the answer.
Yeah, you showed us answer.
Which one? Integer practice activity, this one?
That one.
Yes,
I-
ma'am. We
I
have that
think so.
copy.
Yes, ma'am, I think the one.
Yeah.
Yeah,
Okay.
that's the one, ma'am.
Okay,
That's the
so
one.
what is your question here?
Yeah,
The
answer
number 2.
Huh?
Answer key. Number 2.
So
Yeah.
number 2,
Yeah,
minus and minus is going to be plus. It's going to be plus
Yeah.
6.
It's
Yeah.
It's
going
going to be
3.
minus 3 plus 6. The answer is going to be plus 3.
Yeah,
So it will.
it's 3, right?
Yeah,
No,
3.
It's not 9.
No,
negative
plus.
9, ma'am.
It's minus
answer
9
key
is
is
the
9,
answer,
ma'am.
ma'am.
Yeah, it should be 3, not minus
Who told
9.
you minus 9?
We have
Ma'am,
the
the
answer.
It's in the
answer.
ma'am.
answer
We have
key.
the
Go to the
answer.
answer key at the bottom.
I think it's
Yeah.
not right. It's not
Yeah.
right. What they are telling the rules versus this one, it should not be right.
So yeah, that's very confusing, ma'am.
Yeah,
Very
so
confusing.
True.
yeah.
Ma'am, but in the math
Miss,
rules
that's
it
why I was
says
trying to
change
say
the
that
second
yesterday after
integers.
school.
Yeah,
That's what I was
excuse-
trying to say with that one, with the minus with her yesterday.
Yeah, because minus and minus, they are telling that it's going to be the plus, right?
Yes.
And the
According to
second integers will be changed the sign.
The math rules, okay? Here is the
Yeah,
math
it's
rules.
in the
What
math
about the-
rules.
Yeah, so math rule is telling here, let me open this one. Okay, so math rule is telling you when there is a minus and minus is going to the plus. And if it is plus, it's going to subtract, it's going to be minus 3. Now, if this value is bigger, so it's going to be plus 3. It cannot be. Their answer is wrong.
Oh, that's why, ma'am. That's very
Yes,
confusing.
ma'am. Yeah.
No, you guys follow the math rules, okay?
Yeah, okay. We'll
Follow the math
math
rules. If there is any discrepancy, I'm going to fight for that. You
Yeah,
cannot
okay.
confuse the students for two things. It's going to be one rule.
Yeah, that exactly, ma'am.
Yeah, this is going to be one rule. Except this one, did you find anything discrepancy?
Because why I'm confused.
This is minus 3. Just let me see. This is minus 3. This is going to be 3. This is going to be minus 9. This is 5/7 divided by minus 5/8. So it's going to be, you have to do the calculation. Okay, so this is going to be 8 48 is going to positive 1, 3/4 minus and minus is going to be again plus. So it's going to be, we are going to say 4/6. Oh, there 4/1
and 1/4.
Yeah, 1 and 1/4. Yeah, 4/2/4.
The third one is
Yeah, so plus 1 by, yeah, yeah. So this is into the calculation. Find it out. If there is anything discrepancy between that, let me know, okay? As per the math rule versus this one. This is
Yes,
going to be
ma'am,
minus
okay.
4. This is going to be, see, this is minus 9. Okay, so this one you have to divide. Minus 9 minus 9 is 0. See how they are following
0.
this one here? Minus 9
Exactly.
plus 9 is equal to 0.
Yes.
See why this is going to be then the opposite rule? Tell me. Minus 9, when there are 2, is going to be plus 9. So minus plus 9, its result is 0.
Miss,
Yes.
Miss, and
Yes.
yesterday I pulled that question out to her because I saw the minus 9 and I saw it with the minus 6.
Yeah.
And I pulled that out to her too, and she said it was right. I was giving her as an example. I even take the book up to her and show her an example out of the book.
Yeah.
So I don't know what's going on. I just like it's contradicting.
Follow the math rule. Okay. Whatever may be
Okay.
there.
All right.
Okay, math rule, whatever, because they are following this, they are following the math rule, they are giving here the right answer. Minus
Okay.
9, minus,
All right,
minus
thanks.
9, 0. This is the right answer. This answer is wrong.
Okay, thanks.
They are going to be.
All right, it's 1 o'clock.
Asnet.
Yes, ma'am.
My goodness, this lady is too much. Okay, go.
We gotta respect time here, right?
What?
We gotta respect time.
Yes.
Yeah.
Yeah. Okay, go.
All right.
Okay, Mom.
Good
We'll
rest,
grab
miss. Okay,
Good night.
bye.
Yeah,
Bye.
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 Take
Everybody's jumping to say bye. Okay. Practice all these maths, okay? Okay.
Yes,
Follow the
ma'am.
math rules and
Thank
follow
you.
Yeah.
Thank you, Miss.
Thank you.
Okay.
See you
Okay,
tomorrow.
See you tomorrow.
Okay, bye.
Bye.